Good morning, and welcome to day 2 of DaprCon. All the content from day 1 is now available on demand on the Dapr YouTube channel. Yesterday, we heard from the founders, maintainers, and adopters of Dapr. Well, today, it's your turn. During this half-day workshop, you will have the opportunity to get hands-on with Dapr. This workshop teaches you how to apply Dapr in a microservice application. Follow along coding in Java, Python, or C#, or just sit back, relax, and watch a live coding session. During the day, you can ask questions on YouTube during the live coding session, or on the Dapr Discord for those coding along. The live coding session will be led by Edwin and Sander, and those coding along will have Martine, Tom, and Willem providing support in Discord. So fire up your favorite editor, get comfortable, and get ready to learn how to Dapprize an app.
Hey everyone, welcome to DaprCon Day 2. I hope you all had a great day 1 yesterday. We saw some great sessions by the team, and we really enjoyed it. So today we're going to talk to you about Dapr in a workshop way, and we're going to explain everything about the workshop later on. So you're going to know how to participate yourself or look at us doing live coding. We are going to do this workshop together. So I'm Edwin van Wijk. I work as a solution architect for info support in the Netherlands, and I'm a Microsoft MVP. And I'm joined by my colleague Sander. Maybe you can introduce yourself, Sander.
Yeah, hi, I'm Sander Molenkamp. I'm a principal cloud architect at Info Support. I'm also a Microsoft Azure MVP, and I just really look forward to showing you guys a lot of code today.
Yes, definitely. So we helped write this book that you see on the right here, Dapr for .NET developers. We were asked by the Dapr team if we could participate in that, and we did that together with Robert Vetter, one of the people at Microsoft. So if you want to learn Dapr or you want to read some more in-depth information about Dapr, look it up. You see the link here. You can read it online, or you can download a PDF. Well, Sander and I have been doing some videos for a long time now. We have a channel called .Netflix. So if you want to learn more about Microsoft technology and all kinds of stuff, we have a lot of guests that do great sessions there. If you're interested in that, just check us out. It's youtube.com/.netflix, and then you can see a lot more of us. So while we were writing the book, we actually thought, well, we should have a workshop or something like that to let people actually learn Dapr, because you can read about it, but it's always great to get hands-on and start doing actual coding. At least we think that's great, because that's the way we learn best. So we have quite a program for you today. This is the agenda for the entire 4-hour session that we just started. We're now busy, obviously, with the welcome part. And what we're going to do first is we're going to do a Dapr 101. And little disclaimer, if you're already known, well, if Dapr is already known for you, if you have done some stuff with Dapr, this will probably be really basic stuff. But we added this anyway because we think that also people that haven't done anything with Dapr, it's a great way to start learning Dapr with the workshop. So we want to do some Dapr 101 to get people up to speed. And after that, we're going to introduce the workshop case, because we're going to be working on a case throughout the entire workshop. And there's a sample application with that, and we will Dapprize this sample application during the workshop. And then we're going to provide you with some details. And then basically you can make a choice. You can either watch Sander and myself doing all these assignments that you see there. So adding service invocation, adding pubs up, all the Dapr building blocks. You can watch us do that live. So we will show you how to do it. Or you can either do it yourself. There are some elaborate instructions in the workshop we will share later, and then you can do it by yourself and start learning Dapr. So as you can see, we will be handling a lot of the Dapr building blocks. And actually, you see 2 additional episodes here. That's actors and observability. And this is basically something that we only will show in the live coding session. So they're not exactly in the workshop, but This session is also recorded. So if you want to watch those parts, you can always go back later and watch the recording. So there's no need, if you choose to go hands-on, to go back at a certain time to watch the stream. You can always do that later. And then we will provide links to the individual chapters so you can watch them. And obviously, all the way at the end of the session, there's also some time for Q&A. So if people watch the stream, if you have some questions, stay around for the Q&A, and then we will hope you've learned a lot about Dapr. So let's dive in and do a little 101 on Dapr. What is Dapr? Well, Dapr actually stands for Distributed Application Runtime. And that's quite a broad aspect, right? That's a broad concept. So what you can do with Dapr is build distributed applications. Or if we look at, for instance, microservices, that's a term that we hear a lot associated with Dapr. So if you have an application that consists of multiple parts, then Dapr is for you. And what we see a lot is that when people start building distributed applications, you often have a lot of cross-cutting concerns. So things like, if you want to do pubs up, you need some kind of a message broker. Well, actually calling another service, where does it live? And how do I send something to that service? That's all concerns that you have. How do I handle secrets? All that stuff. And often people have a lot of time invested in creating all kinds of abstractions from these infrastructural capabilities like PubSub or service calling. And that's basically complexity that we don't need. We want to focus on building software, building business software, and adding value basically for your customers. So that's exactly where Dapr comes in. Dapr will abstract a lot of these capabilities and a lot of these cross-cutting concerns for you, so you can focus on the business value. A really important part of Dapr is that it is completely open source. So it originated at Microsoft, but it's completely open source. It is maintained by a community, and everyone can contribute there. So that's really important to understand. If you want to know more, go to dapr.io or docs.dapr.io, and from that website, you will find all the information that you need. So what is Dapr? Well, Dapr basically is a set of building blocks that will be provided to you as a developer for abstracting these cross-cutting concerns that I just talked about. And here you see a list of all these building blocks. So you have service invocation. Service invocation building block can be used to call other services within your distributed application. You don't need to know where it lives. You just say, I want to call service X, and then Dapr will find the service for you and will actually invoke a method on that service. So that's pretty handy. Then we have state management. And beware, state management is not an ORM or something to abstract a complete database, but it is more for storing key value pairs and stuff like that. So keep that in mind if you start looking at these building blocks. Then publish and subscribe. The PubSub pattern, as we know it as a concept, is very important when we look at distributed applications. Event-driven applications is something that you can do by using PubSub as a pattern. Well, the publish subscribe building block from Dapr can help you with abstracting message brokers, for instance. So if you want to use RabbitMQ in your development environment, but you want to use Azure Service Bus in production, then you can use the PubSub building block. Then there's resource bindings and triggers. And these can be used to integrate with lots of different systems. So, for instance, getting a message when an event comes into an event grid in Azure, or sending a tweet or sending an email. You don't want to be concerned with how that works. You just want to use that capability from your software, and Dapr provides triggers and bindings to do that. So that's very convenient. Then there's an actor model in Dapr. So you can use an actor model, which is a certain programming model, which Sander will dive into later on during this session, that you can use, and Dapr provides an actor model implementation for you. Then there's observability. In my opinion, one of the most important things you need when you start building distributed applications, because you need to know what is going on within your application, especially when something goes wrong. So you need insights into what's happening, and observability can give you that. And we will look at how Dapr provides lots of observability out of the box, basically, when you start using it. Then there's secrets management. There's almost always some kind of information that you don't want to disclose to people, right? So think about passwords or certificates or API keys that you need for authorizing to some service. You don't want this to end up in your GitHub repository for people just to read, so that's not good. Secrets management building block can help you with with doing that in a secure way. And we will look at how that works later on. And then there's a little block that says extensible, because it is open source and the team is working still on Dapr and adding building blocks later on. So we will see lots of more building blocks being added to Dapr in the near future. So keep the documentation in check. So how is Dapr able to provide these capabilities to you as a developer? Well, basically through an HTTP or gRPC API. And this is the genius in Dapr. So from every platform or every programming language in which you can do HTTP or gRPC communication, which is basically everywhere, you can use these building blocks through standardized APIs, Dapr APIs. So there are lots of languages that you can use. And there's also often a little bit more convenient way of using Dapr, because there are SDKs for a lot of programming languages. There's one for Python, there's one for .NET, for Java, etc. So there are also SDKs that make it even more easier for you as a developer to use these Dapr capabilities. And then there's also integration with lots of other environments and runtimes. So there's integration of Dapr in Azure Functions. You can use Dapr with Logic Apps or with API management. So there are lots of environments where Dapr will be usable. And there will be more later on, obviously. So this will be more and more in the future. So this is what the Dapr adds, or what Dapr provides to you. So how does it do that? Well, there's an important pattern that you need to adhere to when you start using Dapr. Dapr uses the sidecar pattern. And the sidecar pattern is a pattern that is well known. And basically, the Dapr offers a sidecar that runs alongside your application. So if you look at this picture here, you see application code that is basically a microservice that you created. You start it as a process. In this case, I'm using self-hosted Dapr because Dapr has several ways of hosting it. And this is just as a process on your machine, for instance. The application runs on your machine, and then the Dapr sidecar is also started as a separate process on your machine. And then over the local network, your application will do HTTP or gRPC calls on the Dapr API that is provided by the Dapr sidecar. Well, like I said, there are multiple ways of hosting Dapr. This is self-hosted mode, but you can also run it in Kubernetes. And Kubernetes is also actually the preferred way if you start actually running Dapr in production. And how does that work in Kubernetes? Well, in Kubernetes, you basically deploy containers, which runs in a pod. So in this case, you see the application code running as a container inside a Kubernetes pod. And then when you deploy the application with Dapr on Kubernetes, then the sidecar will automatically be injected into the pod. So a second container will actually be started within the pod and runs alongside your application container. And then just the same as with the self-hosted part, but now they run within the pod. So your application code can talk to the Dapr sidecar over the local network. So that's pretty convenient. And this way, Dapr can provide all these capabilities to your application using the API. So this is how Dapr works. And like I said, this Dapr sidecar pattern is really something that you need to grasp. Also, when you start working on the workshop later on, really think about, okay, what's happening? I'm starting a service and it has a sidecar that runs alongside it. And you need to be able to make sure that you understand that concept. That's really important. So with that, maybe Sander, can you provide a small example of how you can run a Dapr with a sidecar?
Yeah, I sure can. So let's switch over, make sure my screen is shared. Yes. So yeah, let's say we are running a Dapr application in Kubernetes, because as you said, the preferred or the recommended production scenario for Dapr application is Kubernetes. So that would give us a single Kubernetes pod with two containers in it. So the application container, which runs my code, and the Dapr sidecar that Edwin talked about. Now, let's say that this application needs to store some state, some key value pair. Now, with Dapr, that's really easy. I only need to make a call to the Dapr state management API on the sidecar. And as Edwin explained, I can do that using either HTTP or gRPC, or use one of the language-specific SDKs. Now, Dapr will use the state store component, which I configured, to actually store the data. So let's say that in this example, I've configured Dapr to store the state in a Redis cache. Now, if I change my mind, or maybe change environments, I can change the state store simply by modifying that configuration. So for example, if I want to switch out Redis and replace it with a Cosmos DB, I can simply do that just by changing that configuration. So I don't need to modify any code in my application for that. Now let's expand this example a little bit and assume that we've got this second service running in Kubernetes. Now, if I want to call this second service, I don't need to know where it is. I just use my local sidecar. And in this case, I'm using the service invocation API of Dapr. Now, the local sidecar will communicate with the remote sidecar, and that remote sidecar will then invoke the actual service. And later on, we'll look deeper into service invocation, and I'll explain more about the benefits of working this way. But first, I think we've gone through enough PowerPoint slides for now for a workshop. So let's look at a little bit of code to get started. Now, this demo will be in C#, but the upcoming workshop exercises can also be done in either Java or Python. All right, so this is my development machine, which is a Mac, by the way. Dapr has cross-platform support and can run in many different environments. As you can see, I'm using the light theme in Visual Studio Code. I highly prefer that. Edwin highly prefers the dark theme, so that's an easy way to distinguish us. Now, I've got both Docker for desktop and Dapr running here. So when you get started with Dapr and you install Dapr for the first time, you first install the Dapr CLI. So you can see it, I've got it running here. If I type Dapr, you can see some nice ASCII art and then all the stuff we can do with it. Now, after you've installed the CLI, the first thing you do to set up your Dapr environment is to run Dapr init. And that command will install the Dapr runtime binaries and a couple of container images on your machine. Now, there are two variations. You can either use Dapr init-k, that will install Dapr into a Kubernetes cluster. If I just run Dapr init without -k, it will install Dapr in that self-hosted mode for local development, which is what I've done here. So I've already done that, so I'm not going to rerun this command. In this self-hosted mode, the microservices and the Dapr sidecars just run in separate local processes without any container orchestrator. So if I now run Dapr -version, you can see that I've got CLI installed with version 1.4, and that I indeed already ran Dapr init, and now the runtime version that is installed on my local machine is 1.4.3, which is the very latest released version of Dapr. Now, I also mentioned that some container images will be installed. So if we run a Docker PS, we can see 3 containers here. And the first one is the Dapr placement container, which is required when you use the Dapr Actors building block. So the Dapr placement service is responsible for distributing all the actor instances across the available sidecars, but I will get more into that in, I guess, about 3 hours. The second container is Zipkin. Zipkin is an open source distributed tracing system where we can have a look at all the traces between our applications and sidecars. Edwin will show you that when we we will talk about observability. And finally, there's a Redis container, which is used as the default backing infrastructure for both PubSub and state management. And that's really useful, so you've got something that works straight away out of the box. So Dapr binaries have been installed, and on a Mac, that installation directory, I want to type this, it's your home folder or your user folder, and then .dapr. And it's the same on Linux. On Windows, it's your user profile folder, and then .dapr. So let's open that up and see what's in there. So what do we have here? We have a bin folder containing the Dapr binaries. We have a components folder, and we have this interesting looking config.yaml file. Now, this is a default Dapr configuration file. Each application that uses Dapr can use such a configuration file to specify settings for all kinds of things like tracing and metrics. For example, here you can see that tracing is enabled because the sampling rate is set to 1, and that the traces are being pushed to this Zipkin endpoint. And this is the endpoint of the local Zipkin container. You can do a lot of other stuff here. You can also add middleware components here to inject functionality when you make service calls. It's used to configure some security settings. This all looks also a bit familiar if you're used to Kubernetes, because it's in the form of a Kubernetes custom resource definition. But the self-hosted mode, it's just a file on disk, as you see here. If you're running in Kubernetes, though, you need to apply this configuration to the cluster. Now let's have a look at this components folder. So this contains 2 component configuration files. One for the Dapr pub sub building block and one for the state management building block. So let's maybe first look at the pub sub one. So this is a configuration for a pub sub component. Now, first off, this component needs a name, so we can refer to it from our application. So in this case, it's called pub sub. And then very important, in the spec section, you can see the type of the component. So in this case, it's a pub sub component that uses Redis as the underlying infrastructure, as the underlying message broker. Now, the first part here is equal to the name. That may be a little bit confusing, but it's purely coincidental. This component name can be anything we want. We can name this pub/sub full. The type would still be pub/sub.redis, and this would all work. So don't let that confuse you, those two being the same. Then in the spec, we have a bunch of metadata, which differs depending on the type of component that you're configuring. So in this case, we need to tell Dapr how to connect to our Redis server. So we give it the location of the local Redis server that's running in the container, and we give it the Redis password, which is blank by default. And the state store component is very similar. So in this case, it's called state store. The type is state.redis. So again, we are using Redis as the underlying infrastructure. And we also have slightly different metadata. Of course, we still need to tell Dapr how to connect to that Redis instance. But for a state store component, you can also specify if you want this state store to be used to also store actor state. Now, if you don't specify a custom directory when you start your application with Dapr, the runtime will use this default components folder and load these 2 components. So let's see that in action now by creating a real quick, simple sample application. So I'm going back to my home folder. And let's create a new .NET Web API. Let's call this Dapr 101. Let's go into that folder. Now, there are a lot of ways you can interact with the Dapr sidecar. You can just use HTTP requests. So from the .NET or C# platform, I could use just the HTTP client. But I think it's nice to use the .NET SDK. So let's add that. That's just a simple, I can't type. That's just a simple NuGet package. That's called Dapr.ASP.NET Core. Let's wait for that to be installed. And then let's open up this folder in Visual Studio Code. All right. So fail to install yada yada. That's not important right now. I also don't want to generate any assets. Let's keep it simple. Now to use that Dapr.NET SDK, we need to make a change to the startup class first. So in the configure services method, I'm going to add MVC, and then on that object that's returned, I'm going to call add Dapr. This call to add Dapr does 2 things. So first, it registers some ASP.NET model binders, so we can very easily work with the state management building block directly from our ASP.NET controllers, which I'll show you in a bit. It's really nice. Now, secondly, it registers a Dapr client class with the .NET dependency injection framework. You can use this Dapr client class, so let me add a using statement, to interact with the Dapr sidecar. So if you look at the kind of methods this Dapr client exposes, it basically exposes all the APIs that are available on the Dapr sidecar. So there are some service invocation APIs like create invoke method requests. There are some secret stuff, get bulk secrets, some state stuff. Basically anything you can do with the Dapr sidecar is in here. So this is a very nice facade that you get to work with that. All right. So let's add some logic to this application. So let's create a bank application, because banking applications are always really nice and simple. At least they are in demos and workshops. I can imagine they are some of the more complex types of software we can think of in the real world. But let's keep it simple. Let's make an account controller, and we'll just make a banking application that allows us to deposit some money and withdraw some money. And I'll show you how we can use the state management building block to make this a stateful microservice. Okay, so I'm not going to type all of this because I'll just make errors. So I've got some snippets ready and set to go. So this is my account controller. Now, first off, in this controller, we need to know the name of the state store component that we want to use, because a single application can use multiple different state store components. So I've got the state store name in this private constant. And by the way, this is the name of the default state store component that I showed you earlier. Now, our first method in this controller will allow us to get the current account balance using an HTTP GET. And we need to include an account number in that in the URL. So this method takes a single balance parameter of type int. So this is a very opinionated bank, by the way. They only allow us to store balances with round numbers. Now, I've decorated that parameter with a from state attribute. And that attribute is part of the Dapr SDK. It will automatically load the state from the state store. So it basically means don't get this parameter from the HTTP request, but please load it from the configured state store. And that attribute requires two parameters. First, we've got the state store name, and then we have account number, which we use to resolve the key to query the state store with. So because I've passing in here account number, it will get the account number, the real account number value from the URL, and it will use that value to actually query the store. And then the only thing I have to do to implement this method is to return that retrieved value. Now, if there isn't a value for the given account yet in the Redis database, we'll just get back the default .NET default value for this type. And for integer, the default value is 0. So that works out perfectly for this use case. Now also note that I'm using a simple value type integer here, but you can use any .NET type as long as it can be serialized by the system text JSON serializer. All right, let's look at this next method, which allows us to deposit some money in the account. I'm using that from state attribute again, but instead of just an integer, I've now declared my parameter as state entry of int. Now, state entry is a very useful type. It's a wrapper around my value that also allows me to update the value and save it back to the state store. So what happens here, the balance will be loaded from the state store. I increment that value by the given amount. Then I'm saving the result back into the state store, and I'm also returning it to the client. Now the withdraw method is mostly the same with The only exception being that, of course, now I subtract the amount from the current balance. All right, so let's see this in action. So let me open up my console window here. Now, normally, you would run a .NET application just by typing .NET run. But in this case, I also need to instantiate a Dapr sidecar process. So for that to work, I need to use Dapr run. So I'm using that Dapr CLI again. Now I need to give this application a unique ID. So let's call this bank. And I need to tell Dapr on which port my application can be reached. Now, a default .NET application exposes 2 ports. So one for HTTP, which is 5000, and one for HTTPS, which is 5001. And that default template I used also includes middleware to redirect any incoming HTTP traffic to the HTTPS endpoint. But that redirection breaks the communication between the Dapr sidecar and my application. So there are 2 possible solutions for this. I can remove the middleware from my .NET application and simply use HTTP, or I can configure the sidecar to use the HTTPS port, but then I also need to remember to include this app SSL flag to tell Dapr to connect using HTTPS. And then finally, I need to tell the Dapr CLI how to run my actual application, and that's still .NET run. So let's start this. You can see, well, 2 things actually. You can see, first off, there's a lot of logging from the sidecar itself. So you can see Dapr starting up, and you can also see it finding and loading those components. So here, it's my highlight color is not the greatest, but I hope you can see here it says component loaded, name state store. So it found that state component and it loaded it. And then all this more colorful logging with app prefix by app, that's the logging from my .NET application. So you can see both the logging of your application and the sidecar in this single window, which is really nice. So let's test it and see if it works. So I'm going to create a new file called this sample.http, and I'm going to use the REST client plugin for Visual Studio Code to test this. So let me just switch this out. Okay, and so first let's see if we can get a balance. So let's open a new account called this DaprCon, send that request. You can see that it returns 0. So right now there's nothing in that new account. Now let's deposit some money. So again, the URL is account DaprCon and the amount of money I want to deposit. So let's say I want to deposit $19 and run this a few times. You can see that it's really stateful because it increases the value, the current account balance. And of course, I can also withdraw. I guess you will all believe this, that it will work as well. Now, let me prove to you that it's really, really, really stateful. So if I now exit my application, and I try to get the balance, then I get this error message, connection was rejected. Yes, of course, because there's nothing running. So let me start the application again real quick and retry that command. And you can see that I get back the balance where we stopped the application. So it's really stateful. Now think of all the things that we didn't have to do to make this work. We didn't need to add any specific SDKs or libraries for Redis. We didn't need to write any code to open or manage a connection to Redis. In fact, we use Redis, but we didn't need any Redis skills at all. And on top of that, this application can now really easily change from using Redis as its underlying data store to something else just by changing a component configuration file. And that's something I will show you later during the workshop exercises when we look a little bit deeper into the state management building block. All right, now let me switch back to my PowerPoint presentation and show you this impressive slide there are a lot of different components already available to be plugged into Dapr. And now I believe this slide's already a couple of months old now, and the number of components have only increased since then. Now, of course, as Edwin told you, Dapr is fully open source. So even if you're missing something, you can always create an implementation yourself, contribute it back to the community. That's always highly appreciated. So that's my quick introduction to Dapr. Edwin will now take you through the introduction of the demo application that we will be using throughout the remainder of this workshop. And after that introduction, you can choose if you want to keep watching us go through all of these exercises in C#, or if you want to do the exercises yourself, take on the challenge and do that in C#, Java, or Python. So over to you, Edwin.
Yes. So let's look at the workshop case and the sample application. So the case that we used for this application, we wanted to have a very simple domain. So we could use a bank or an insurance company, but we wanted it to be really simple, and this is what we came up with. So this is something that we have a lot on a lot of Dutch highways. So there's a stretch of highway, in this case it's 10 kilometers long, and then they place some entry and some exit cams above this highway. And then when you drive under the entry cam, a picture is taken of your license plate, and the system will store that. And then when you drive under the exit cam, the same thing happens, and then the system can calculate what your average speed was on this stretch of highway. And if this is above the limit that's allowed on this stretch of highway, you will automatically get a fine. So you get a speeding ticket on your doormat. And how does that work? Well, basically, there's a Department of Motor Vehicles that has information on all the vehicles in the Netherlands and the owner, obviously. And there's the Central Fine Collections Agency. So when the system works out that you drove too fast on this stretch of highway, it will send a message to the Central Fine Collection Agency. The Central Fine Collection Agency will then query the Department of Motor Vehicles to get information about the vehicle and its owner, and then it will send the speeding ticket to your address. So that's a pretty cool system if you look at it from an IT perspective. But if you're a driver on Dutch highways, it is less. It's not so nice, and it's less popular than the IT solution.
I guess you have a lot of experience with it, Edwin.
I had until I got cruise control on my car. Now it's a little bit better. So but I received some fines this way. So I'm pretty. I'm a user actually. So this is a pretty simple domain, and what we did is build a simple distributed application. Let's call it a microservices application, but it's a little bit stretching it. But okay. And these are the parts that this application consists of. And really make a mental note of this, because you will be working with these services throughout the entire workshop if you start going hands-on. But also if you keep watching us do live coding, we will be going back to these services all the time. So what are the parts? Well, first of all, we have the camera simulation. And this is just a .NET console application that will simulate cars driving under the entry and exit cameras. So for simulating that, we can send a message to the /entry cam or /exit cam endpoint on the traffic control service. And the traffic control service is just an ASP.NET Core Web API that offers these two endpoints. And you can just send an HTTP request to it with the license plate of the car. And then it will be registered as an entry or an exit instance. The traffic control service will work out based on the timestamps, whether or not you drove too fast. And if it detected that you drove too fast or that the car drove too fast on the stretch of highway, it will send a speeding violation message to the fine collection service. And it uses the collect fine endpoint. Also, this fine collection service is just a basic .NET Core Web API application, and it offers the collect fine endpoint. It will then, in turn, call the vehicle registration service to get the information for the vehicle and its owner, and it will send an email in this case. So we've used email as the way of getting the ticket to the person. It will send this speeding violation and the ticket to your home address. So these services we're going to be working with. As I said, when we start out with the workshop, and also when you're doing the hands-on assignments, these will all be just communicating over plain HTTP. So we're using just the .NET HTTP client for sending JSON requests to the different endpoints that are offered. So this is the starting point, basically, of the workshop. But during the workshop, we will be Daprizing this entire system. And what I'm now going to show you is basically build up the end result. This is what you will end up with once you go through all the assignments. And as you can see already here, the traffic control service, the fine collection service, and the vehicle registration service, they will be Daprized. So they will have a Dapr sidecar eventually. The camera simulation will still be just a .NET application. So keep that in mind. So as you could see in the agenda, we have sections for all of the Dapr building blocks that we are going to use. And first of all, we're going to use service invocation. And we're going to use that between the fine collection service and the vehicle registration service. So once the fine collection service receives the speeding violation message, it will use service invocation to find and call the vehicle registration service, and it will receive the information for the owner and the vehicle. So that is where we're going to use service invocation, and that will also be the first assignment that you will do if you start working with the workshop. The second building block we're going to do is pub/sub. So when the traffic control service has detected a speeding violation, it will send it to a RabbitMQ, which we will use as the message broker in this case. And this RabbitMQ will get this message, and the fine collection service will subscribe to these messages, and they will be sent to the collect fine endpoint by the Dapr sidecar. And we will look into how that works in detail. This, of course, is one of the things that you actually want in a distributed application, because if the fine collection service would be offline for some reason, maybe an update or some crash of the system, then you don't want these speeding violations to be lost. Well, actually, me as a driver would like that, obviously, but you know, the Dutch government doesn't like that. So that's why we implemented a message broker here. The third thing we're going to use is state management, because in the initial version of the traffic control service, the entry and exit timestamps and the information of the vehicle will just be kept in memory. And of course, this is also not good if you want to survive a restart of or a crash of the traffic control service. So what we do in the third part is that we will add state management to save the entry and the exit cam state of the vehicle. The next one is going to be output bindings. So what we want to do is from the fine collection service, as I said, we will use email for getting the speeding ticket to the actual driver. We will use email. And because there's an SMTP component for Dapr, this is what we're going to use. And this will also actually send the message to an SMTP server that we're going to be running. And this is basically also something that we will get to later on if we look at the workshop, but we will actually be running these infrastructural components during the workshop as Docker containers. So we're going to have a Redis, we're going to have a RabbitMQ server, and we're going to have an SMTP server running. But that's all described in the documentation. So the next one we're going to use is input bindings. So instead of using HTTP to getting the simulated cars from the camera simulation into the traffic control service, we will actually be using an MQTT broker. In this case, it's Mosquito, which is a lightweight MQTT broker. And then the camera simulation will use the MQTT protocol to get the messages into the traffic control service using the Dapr sidecar. So that is the fifth one. And then finally, the sixth one, we're going to use secrets, because the fine collection service has some credentials for logging on to the SMTP server, and it uses some internal library that uses an API key. And these are obviously, these are secrets that we don't want in our code base. So that's why we're going to use secrets management for getting these secrets at runtime. So this is basically the end state. So after doing all the assignments, this is what you will end up with, and then you can start experimenting with Dapr. And along the way, we try to explain as much as possible how this works and how you can configure it, and et cetera, et cetera. So like I said, keep this in your head, make a mental note of this, because this is what you're going to be working with throughout the workshop. So let's look at the application. I'm going to switch over to my Visual Studio Code. And this is the end solution, so to speak. So this is the Dapr traffic control end solution, and I'm going to show you how this runs. But first, let's look at some code here. You see the individual services. So you see the vehicle registration service, the fine collection service, the traffic control service, and the simulation service. And if we open up, for instance, the vehicle registration service, you will probably recognize, if you're a .NET developer, you will recognize this as just a simple web API, an ASP.NET Core web API. There's a startup, there's a program. This is not yet in .NET 6. We're busy porting everything to the new .NET 6 that will be going GA in November. But for now, this is still .NET 5. And also, if you look here, we have a controller, which is just an ASP.NET controller, as we know and love. We have some models in here, which is just some C#, plain old C# objects. This is the information for a vehicle with the brand, the model, the owner name, and the owner email. So it's just, the code is not very complex. So that's not what this sample is all about. And all these services are just web API services. Well, like I said, we have some infrastructure in this sample because you saw RabbitMQ, you saw a mail server, you saw Redis. That's all running already on my machine. So if I go over here to my Docker plugin, you see here that I have a mail dev server, which is my SMTP server. I have a RabbitMQ, and I have a Mosquito server already running on my machine. So that infrastructure is already up and running. In the documentation, you will find a description on how to start that. So now what I'm going to do is I'm going to open up my terminal window, and I have basically 4 terminal windows open here, each for one of the parts of the solution. So we're going to start with the VRS, the vehicle registration service. And what I'm going to do is I'm going to give the commands for starting this service, just as you saw Sander do in the 101 bit. So I'm giving it the application ID vehicle registration service. I'm giving it some ports. Again, this is all described in the documentation. But an important part is that I specify a components path. So I say that I want to use specific components that are part of this solution. And here we configure all the building blocks that we use in the solution. And we're going to go into that in the detailed section. And then eventually the command for running it is .NET run, because it's just a .NET application. So if I do that, I got a lot of logging from Dapr, and people that know the ASP.NET Core templates, this is just the logging that comes from my application. So everything seems to work. And I'm going to do the same thing for the fine collection service. So that is the service that will call the vehicle registration service and will send the emails. This is also up and running. One thing that you see here actually is that you see information about this service using PubSub. So what you see here is that the app is subscribed to the following topics: speeding violations through PubSub. And we're going to look into how that works later on. But you see that this is already actually using the RabbitMQ server. There's also an error in here that says there is already a subscription, but this is an issue that's already been assigned and will be fixed in one of the next versions of Dapr. Then the traffic control service. I will start it the same way, also with the Dapr run command. And, oh, it's already running. That's strange. I have to use traffic control, obviously. What's really important is that you see with all these services that they are using different ports. So you see here, for instance, 6000 as the application port, and you see 3600 for the Dapr sidecar. For the other services, those are other port numbers. And this is because we don't want any port clashes on the machine, because this is all running on my local machine. So keep that in mind when doing the workshop. So now I have all my services up and running. The last thing I'm going to do now is start the simulation. And like I said, this is just a .NET application. It doesn't do anything with Dapr. It just sends MQTT messages to an MQTT broker. And then through the magic of Dapr, as you can see here, these simulated entry and exit cam events come into the traffic control service. And also, if you look closely here, you see that there are already some speeding violations in there. So if we were the Dutch government, we're already making money. So that's pretty awesome. And if I go to the fine collection service, I can also see that it is actually sending speeding tickets to people. And in this case, it worked out that the TR007H, that will probably be an Aston Martin. No, it's a Mercedes B-Class, and it is owned by Laverna Fischer, so she will get a ticket for this one, for this speeding violation. And the vehicle registration service will log that it is retrieving information for all the license numbers. So this is all working. And now to let you see what's going on, I have here I will clear the inbox for now to show you that they're coming in. But the mail server that I'm using, the SMTP server, it acts as an actual SMTP server, but it doesn't send out actual emails. Instead, it also offers some kind of an inbox, and all the emails sent to the SMTP server are shown in this inbox. So you can see actually here that I have a speeding violation, and I can see for who it is and what kind of car this person was driving. Oh, and this was a very fast driver, so they have to go to the prosecutor to explain why they were driving so fast. So you can see that the actual emails are being sent. So this is the end state. So this is something that you will be creating during the workshop, and well, I hope you have fun doing it. So that is the application. So let's go back to the slides now, and now it's time to start introducing the workshop, because now the time has come for you to make a choice, and we will introduce that in a moment. But with the workshop, you will start with this application already up and running. So you don't have to build anything yourself. You just have a working application, but it is communicating over HTTP. And then during all the assignments, you will, as Donovan would say, rub some Dapr on it, basically, and you Daprize the application. This is a very important information, and we will be sharing these links also in the chat momentarily. But these are very important ones. So the first one you need to go to is this repository. It's up on GitHub. It's a public repo, and I will just click on it to show you what's going on there. So if you go to this repository, and you can just open it up in your browser and leave it open, because you can just click through it. And then I will scroll down a little bit. All the information that I've just presented is also in here. So excuse me for scrolling. I'm trying to do this slowly as possible. But then at the end of all the information about the prerequisites and everything, you can go to the assignment. And these assignments, you can just click through them. So if you go to assignment 1, you will get information about what is the goal of the assignment. And then basically you can go to step-by-step instructions for the technology you're going to select. So you can do it either in .NET or in Java or in Python. Now, for the sake of it, let's do .NET and click on it. And then you will come to the step-by-step instructions for this assignment. And it will walk you through how you can do all the steps to get the goal for this assignment, well, to reach the goal. And then once you're done with the assignment, you can just go to assignment 2, and it's the same thing again. You get a description, you get some information about what you're doing, if you look at what you're Daprizing, and then you go to the detailed instructions for the individual technologies. So that's basically it. Then there are some other repositories, because this is the workshop repository with the descriptions. And then for each of the technologies, C#, Java, and Python, there's a separate repository which contains the source code. And it will contain the start solution for you to get to work on. And then through the assignments, you will Daprize that application. These links are actually in the workshop description, so you will find them automatically. What is really important is that you double check or maybe triple check whether or not you have all the prerequisites for the workshop installed. They're also in the workshop description, but they were also shared beforehand in the blog post about DaprCon. So make sure you have these installed, and then you can start following the step-by-step instructions. And we would really like it, because we are going to give you the link to the Discord server in a moment, because all the communication will go over Discord. If you have an achievement, so you created something and you reached the goal of some kind of the assignment or whatever, please share that, because we really want to know how far people are, what's going on, what you're doing with the solution. And if you go completely off the rails and off the description and create something yourself, which is pretty awesome, please share that.
Even better.
Even better, yes. So go to town on it. And obviously, if you have some issues, there are proctors that are available in Discord to help you get unstuck. And who are these people? So these are the people that will be in Discord, already are in Discord right now. We have Robert Vetter, which is the guy we wrote the book with. So a very great guy. He already did the workshop before within Microsoft, so he's very knowledgeable about what's going on there. The same goes for Jordan Bean, also something for Microsoft. He already did the workshop before, and they will be proctoring for C#.net. So if you, during the workshop in C#, you can hit them up for any questions. Then we have Maarten Mulders and Tom Coles, which are colleagues of ours from InfoSupport, and they will be proctoring for the Java workshop. So if you have any Java questions, just find them on Discord and you can ask them. And then finally, we have Willem Meijns, which is also one of our colleagues, and he will be proctoring for Python. And maybe a little accolade here. Maarten actually was the creator of the Java version of the workshop. So they're not only proctoring, but they are also the authors of the specific technology workshop. And Willem is the author for the Python workshop. So if you don't have any questions, please thank him for doing this, because I think it's really awesome that we can do this workshop in 3 technologies. And that's also what Dapr is all about. It is cross-platform and it is cross-language. So that's really awesome. And then last but definitely not least, we're talking into a camera, but everything is running smooth. And this is because the guy behind the scenes, Pierre Roman, he's a senior cloud advocate at Microsoft. You see his awesome setup here on the right. This is actually the setup that he's using. And he's making sure that this stream and also the day 1 of DaprCon, that runs smoothly. So thanks, Pierre, and you're doing a great job. So thanks for that. So now the time has come. If you want to get hands-on and if you want to get to town on the hands-on parts of the workshop, then we invite you to go to the Discord channel. And obviously, you can still keep listening to this channel, but it might be a little bit confusing because maybe you're way faster than we are here. But then go to the Discord channel, find the channels that are created there. You have some text channels, but also some speech and video channels, so you can share your screen maybe with one of the proctors if you have an issue. So go there. And if you want to watch everything being done for you, then stay in the YouTube channel, and then Sandra now will start live coding and doing all the assignments basically through live coding and demoing. So that's it. We really hope that you have a lot of fun, because that's also one of the goals here. It's not just learning Dapr, but have fun and make sure that you have a great day working with Dapr. Did I forget anything, Sander? Do you want to add anything?
No, I think you covered it pretty well, Edwin.
Okay.
And
so then, yeah?
No, go ahead.
Yeah, so then people that want to go to Discord, have fun. And at the end of the workshop, so if we're done at, noon Pacific, I guess, then we will also be joining the Discord channel. And then we hope to see lots of people still working on it and having fun with Dapr. And maybe we can answer some questions. So
and that Discord channel will stay alive for a couple of more days, right? So
exactly.
If the day after tomorrow, maybe in a couple of days, you've got some time, you're working on it, you've got a question, don't hesitate to put it in that Discord channel, and we will keep monitoring that for a couple of days.
Yes. And maybe a last one. If you find any issues with the workshop, please send in an issue, or maybe even in PR, because we want to make it better and better. So if there are any issues or things are not clear, let us know and we'll update the workshop. So with that, thanks so much if you go over to Discord for listening to the first part, and anyone that keeps watching the stream, we will go on and start with the live coding stuff. So with that, Sander, you're going to do the first one, service invocation. So I will switch over to you, and then you can start.
Yeah, great. So for everyone who is still here, you've chosen the lazy path, which is a good sign for a developer. So congratulations. We are going to start with service invocation. Pierre, can you switch to my screen?
Yeah, and I will share the link. By the way, people are asking for the link, so I will share it on YouTube.
Yeah, it might be good to add that to the comment section.
Yeah.
Okay. Thank you, Edwin. Okay, so let's talk about service invocation. Now, across distributed systems, of course, services often need to communicate with each other, and they often need to communicate directly with each other. So, for example, in a non-Daprized application, you could simply use direct HTTP calls between services. So let's say we have this Python app, and we have a Node app. And the Python app makes a direct request to the Node app over HTTP. Now let's look at this URL. It obviously needs to contain the IP address of the Node application. It needs to know the port of the Node application, otherwise it cannot call it. So the Python app needs to be aware of where that Node app is physically located. Now look at what changes when we introduce Dapr service invocation. Now, instead of directly calling that remote service, the Python app will now call its local sidecar. So that HTTP request is now a call to localhost. And here 3500 is the default port number, a default HTTP port of the Dapr sidecar. So the Python app does not need to know where Node app is located. Now, in this call to the sidecar, we also need to include the app ID of the service that we want to call. So in this case, it's Node app. And we need to include the specific method or HTTP route that we want to call on the remote service. And then in the body, we can simply include the request payload. So now the call is received by the Dapr sidecar, and the sidecar will perform service discovery for you. If you are running in self-hosted mode like we are, then Dapr uses multicast DNS for service discovery. If you run in Kubernetes, it's a little bit different because it will use the Kubernetes naming servers. And as of, I believe, Dapr 1.2, you can also configure Dapr to use HashiCorp console for naming resolution. And that's a really great addition to Dapr because it allows you to host Dapr in a lot more different scenarios. Using any of these methods, the point is that Dapr will know where the remote service is located. And then it can forward the call to the remote Dapr instance. And it does that using gRPC. So all the Dapr sidecars, the communication between them is always gRPC. And then finally, that remote Dapr instance will then call the Node application. And any result from that request will simply flow back the same way to the original caller. All right, so why exactly go through all of this hassle just to make a simple service call? Well, there are a couple of benefits that Dapr can provide now that the traffic runs through all of these sidecars. So first of all, services are, of course, now more loosely coupled because they don't need to know each other's addresses anymore. But also, if a service call fails, then Dapr can automatically do some retries for you. Service calls are also automatically secure because Dapr uses MTLS and certificate rotation for you to encrypt the traffic between these services. And finally, this is great for observability because the calls can now automatically be traced, which Edwin will demonstrate later on. So there are a lot of benefits of having service invocation be done through Dapr. Now, going back to the traffic control application, this first demo will focus on the communication between the fine collection servers and the vehicle registration servers. So whenever the fine collection service registers a fine, it needs to get some vehicle details from that vehicle registration service. And at the start of the demo, that is still implemented as an HTTP call. And in this demo, we'll change that implementation to use Dapr service invocation. So the end result will be like shown on the diagram here. All right, so let's switch to my Visual Studio Code instance again. You can see that in the meantime, I've opened up the repository for the workshop. And this is basically the main branch. So this is the state that you would see if you would check out the repository yourself and haven't done any changes yet. So let's look at the vehicle registration service. Now this is the service that we want to call. So this is our remote service. Now this contains a vehicle info controller. Vehicle info controller, which is just an ordinary ASP.NET Core controller. And this has a single endpoint, get vehicle info for retrieving the vehicle info. So when this endpoint is called, the given license number is used to look up the vehicle info in a repository, and then that info is simply returned to the client. Now, the repository that we are using, that we are getting injected here in the constructor, that is implemented in this in-memory vehicle info repository class. And it's really a simple class. It just contains a lot of constants, and it basically provides some random combination of the vehicle details. So let's start this service. So I've got 4 different terminal windows here set up, one for each service. And I'm not going to use Kubernetes. I'm not going to use Docker Compose or something like that. I'm just going to use the plain self-hosted mode and start all these services directly from the command line. That makes it really easy and fast for me to stop and start services while we are making changes to the code in this workshop. All right, now I have some little snippets that I can use like this. So what we are going to do, we are going to start it again using Dapr run. The application ID for this service is going to be vehicle registration service. And then I need to specify on which port my app is listening. And I also specify the ports for the Dapr sidecar that I want to use. Now, because I'm going to run multiple Dapr processes on this single machine, I need to use different port numbers for each sidecar, otherwise I will get port conflicts. So this is the way to set it up. And then, of course, I want to execute .NET Run. So now we're running a Daprized version of the vehicle registration service. And as you might have noticed, we didn't need to change any code for this to work. The vehicle registration service is still just a simple web API listening for requests. Only now, other services will be able to call this service through a Dapr sidecar. So let's move over to the find collection service. Let me close this up. This will keep running even with the window closed. So let's look at the find collection service. And specifically, let's go into this proxy folder and look at this vehicle registration service class. So this is a proxy class that is used to call the actual vehicle registration service. It's pretty simple. It just uses an HTTP client instance to make the call. Now, without Dapr, we needed to know where the vehicle registration runs. So we needed to know this specific endpoint for the vehicle registration service. But now, when we use Dapr, we only need to know where our local sidecar is. So we can change this URL with this other snippet I've got here. This. So let's look at this new URL. So I'm still going to localhost because my sidecar is running next to my process. The sidecar of the find collection service will be running on 3601. So that's the sidecar port. And then I'm calling that Dapr invoke API and ask it to please make a call for me to the vehicle registration service. And when you found that service, please invoke the vehicle info / license number route. So let's see if this works. Let's go back to my terminal. Let's go to terminal window for the find collection service. Let's run that as well. And that's always very interesting. Could find project to run. So I'm in the wrong folder here. So let's go to the find collection service folder. And now it will be able to find that C# project. All right. So that is running. And now let's start that simulation. So the simulation at this point hasn't been Daprized yet. It just makes direct HTTP calls to the traffic. And then when somebody drives too fast, we should be seeing some log entries in the find collection service. Again, same problem. Need to go to my subfolders before I try to run applications, making mental note. So this is starting up. if we go to the traffic servers, which I had already started previous to this demo, you can see that traffic is being generated. We get some entry and exit events from the cameras. And then if I go to define collection servers, you can see that it's quite busy actually sending speeding tickets. So we're earning quite some money here. And the vehicle registration servers, you can also see those calls for vehicle information coming in and being returned to define collection servers. So this is working great. And it's really important to grasp that sidecar pattern use here. So again, just to summarize, define collection servers calls the vehicle registration servers by calling its own local Dapr sidecar. And the Dapr will find the vehicle registration service based on that app ID, which was part of the URI. So moving on, let me stop this simulation for now. Let me also stop define collection servers because I'll make some changes to it. And let's go back to this proxy class. Because this is all nice and well, but you know, it's a pretty long URL. It's maybe a little bit messy in this C# code base. So maybe we want to keep these URLs closer to the original URLs. For example, because maybe we're in an existing code base and we had these route or path parts of the URL. Maybe they were hard-coded in an existing code base and we don't want to change that path to be like v1.0 invoke vehicle registration servers. Now, there's a way to do that, but first let me rewrite this simple one-liner into this. So this code is functionally exactly the same as the code we had before, only a little bit more elaborate. So now we explicitly create an HTTP request message. It has the same URL as we just saw. I didn't change that. We then send the request using an HTTP client. We get back the response. We deserialize it into a vehicle info object and we return it to the client. The reason I've changed this code is that now we can add HTTP headers to the request. So I can let Dapr know which servers to call by including a Dapr app ID header. And when I do that, I can skip this whole part of the URL. And I can shorten it like this. So we still need to call our local sidecar. So that part's the same. But now this other part, this route part of the URL, hasn't changed from the original URL. So this is a good option if you want to keep those routes the same if you're Daprizing an existing code base. Now these are all examples where we use regular HTTP client to make HTTP calls. So there's nothing specifically .NET or C# about this. We can make these calls from any platform. So now let's look at some C# specific functionality by adding the Dapr.NET SDK. So first off, we will need to add the NuGet package for the SDK to the project. So let me check. I'm in Fine Collection Server, so this is the right one. I'm simply going to do what I did in my first demo, just .NET add package Dapr.ASP.NET Core. Now, the nice thing is that Dapr offers really rich integration with the HTTP client. So the Dapr SDK contains a special HTTP client message handler that can rewrite the URIs of outgoing requests. So instead of doing all of this, I can do this. And this is even better because now we've got this nice short URL. You can see here that if we use the SDK, then we use the application ID as the hostname. The route is still the same as the original URL. And in this case, we don't need to send any headers. So this is really nice. And that special HTTP client, which is configured with that special HTTP client message handler, that will automatically rewrite this URL to its longer form. In fact, If we configure this HTTP client with the app ID as the base address, we only need to include this route part, which is even nicer. So now we're at a point where you cannot even see from this code that we're using Dapr to make these servers call. We're just using HTTP client in a way that we're actually pretty used to as C# developers. So I really like that. But to make this work, we will need to make some changes to our startup code. So let's go over to my startup class. And let's find the registration of this server. So here it is on line 26 and 27. You can see that I've added HTTP client support, and we also registering that proxy class as a singleton. So I'm going to delete those 2 lines. I'm going to replace it with a single call to add singleton. So what we're doing here is we register a proxy class as a singleton object. And with that registration, we provide this factory lambda function. Now, when that factory function is called, and I need to get rid of my red squigglies here. But when that function is called, we create a new instance of that special Dapr HTTP client by calling DaprClient.create invoke HTTP client. And that method takes 2 parameters. So the first one is the application ID of the service that we want to call. And the second one is the location of the Dapr sidecar. Now, if you use a container orchestrator such as Kubernetes, you can just use the default ports for the sidecar. You don't have to specify this. But again, because I'm running multiple Dapr processes on this single machine without any isolation, I need to use different port numbers, and I need to specify this explicitly. So then finally, once I've got that special HTTP client, I simply return a new instance of vehicle registration servers, and I give it the constructed HTTP client. So with that set up, everything should still work. So let me go back to define collection servers and run it again. Yep, there it is. And let me go over to my simulator and run that again. And let's see if this still works. So we should be in a, oh, there we go. People are driving really fast today. So here you can see speeding tickets are still coming in. So that means that the vehicle registration service is still being hit. So this all works great with the Dapr.net SDK. And we'll also be using the .NET SDK for all the other demos that follow as well. So that's my demo for service invocation. So to wrap this up, it's really nice that the Dapr.net SDK works so well with the HTTP client class. HTTP client is a well-known class that many developers already use in their code. So it allows developers to reuse their existing skills. It also supports many advanced scenarios like custom headers, full control of requests, and response messages. And it integrates really nicely with a lot of existing frameworks like Refit and Poly. So Edwin, I think now would be a pretty good time for a break before we continue with your PubSub part.
I think so, yeah.
We are located in the Netherlands, where it's like 6:19 p.m. So in Pacific Daylight Time, that would be like, I don't know, 9:19 p.m.
Yep.
So I would suggest let's take a break for like 10 minutes and
like
start at 9:30 again.
Yes, that would be a great idea.
All right.
See you all back at 9:30.
See you soon.
And we're back. Welcome back, everyone. I hope you had a great bio break or drink break. I know I did. I drank some water. And the next part we're going to look at right now is pub/sub, or publish and subscribe. You probably know the pub/sub pattern as a integration pattern, so to speak, for sending messages without knowing which receivers you have, or even if there are receivers, so to speak. So you just publish the message to a broker, and then other systems can subscribe to this broker and get the messages. The really cool thing here is that for pub/sub to work, usually you have some kind of middleware, some broker or some system that you use for storing the messages and for letting people subscribe to these messages. So if we look at how pub/sub works with Dapr, here you see an example of, in this case, a card service that will use Dapr for publishing a message. The Dapr API that is offered by the Dapr sidecar offers a pub/sub endpoint. So what you can do from your application is call this endpoint. And here you see an example. So in this case, I'm using the publish API, Dapr v1.0 publish API, and I'm using pub/sub and orders. And these parts of the URL, these are the pub/sub component name, so the name of this pub/sub component you want to use. You can have multiple. So if you have multiple pub/sub components configured for your application, based on the name, you can select one. And then also you have to specify the topic that you want to send the message to. And then the payload, in this case, is just a JSON document that you send. And in this case, it's some kind of an order with a customer ID, a product ID, and an amount of things to order. So these are really important. So the pub/sub component name and the topic. And the topic is basically, let's call it the mailbox that you send the message to. So when the Dapr sidecar gets this call, it will pick up the payload and it will send it to the configured broker for the pub/sub component in this case, and will send the message there. And you see a couple of examples here. So you could use Redis or Nats or Azure Service Bus or RabbitMQ. And the cool thing about it is that you can switch between these different brokers without changing a single line of code in your own application. So it is all configuration that is handled by Dapr, and that's the cool thing about these abstractions. And then other applications, or a application, but this can also be multiple, can subscribe through the broker on this same topic. So in this case, the shipping service and the billing service are both subscribed to the orders topic. And then the message will be sent to each one of them, and they can handle this message accordingly. You can also see in this example that each of the services is called on a different endpoint. And this is really important. So the shipping service has an order endpoint, and the billing server has an order processing endpoint, as you can see in this example. And it's really important to notice that for the application that subscribes through Dapr to this topic, this will just be an HTTP call. So if you already have an order endpoint, you can use that for it to be called by Dapr when a message comes in to the specific topic, in this case, the orders topic. So that's really important to grasp here in this example. So if we look at the Dapr traffic control example, as we told, this is where pub/sub is being used. So the traffic control service will be the publisher in this case, and the find collection service will be, in this case, a single, but this will be the subscriber. And we're going to use the speeding violations topic on the RabbitMQ broker. So this is what we're going to do with Dapr traffic control. So let's look at a demo of how that works. So we're back in Visual Studio Code. Here you see the solution again with the different services. And the first thing I'm going to do is, because I need a broker, so I will be starting a RabbitMQ server on my machine. And the way I'm going to do that is I'm going to use Docker. I'm running Docker desktop on my machine. So I have this command on the button because you don't want to see me type, but this is how you can do it. So I'm starting here with Docker run. So I'm going to use the Docker run command. And I'm going to use the RabbitMQ management Alpine version 3. This is just a Docker image that is up on Docker Hub. It's the default image that is created by the maintainers of RabbitMQ. The name of the container will be DTC RabbitMQ, or Dapr Traffic Control RabbitMQ. And I'm exposing two ports, namely 5672. This is for the for sending and receiving messages, but also 15672, and this is basically the management console that I can use. So RabbitMQ, if you use this image, has a built-in management console, which is just a web application, and you can contact this application on that predefined port, so 15672. And if I execute this command, I will only get some hash of the container being started on my machine, and now it is running on my machine. So if I go back to the Docker overview, you can see that the DTC RabbitMQ server is actually running on my machine now. So I have an actual broker up and running. So that is the prerequisite. So first of all, let's dive into what I need to do in code to make sure that the traffic control service is able to send messages to the find collection service through this broker. So what I'm going to do is I'm going to dive into traffic control service, and we're going to change some code here. And first of all, what I'm going to do is I want to use different components than the default one. So as Sander showed in the 101, the Dapr 101 session, on your machine in the home folder, there is a .dapr folder that contains default component configurations. And what I want to do is I want to change them. So I want to use different components, and I could put them in that folder, but I just want them to be part of my solution. So I will create a separate components folder. So I will add a folder here in my solution, Dapr/components. And then I'm going to copy over the default components from my home folder into this folder. So I'm going to be in the Dapr/components folder, and I'm going to copy the components from my home folder. In this case, it's part of my user profile.dapr, and then I will copy them into this folder. And now you will see that I have a pub/sub and a state store. This is what Sander already showed you in the 101 session. Because this is the pub/sub part, I'm going to look at this file, and this is the default configuration that comes with Dapr. And here you can see that Redis is being used as the default message broker. But we're going to change that because we have this cool RabbitMQ running on my machine. So I'm going to remove this. I'm going to paste in a default component configuration for RabbitMQ. And you see it's a bit more elaborate. There's some more stuff in there. And let's go through this configuration file. So first of all, we see it's a Dapr configuration file. Obviously, it is a component, and the type of the component is pub/sub.rabbitmq. So now we know that we're going to use the RabbitMQ broker for pub/sub. The name is pub/sub. Again, don't let this fool you. This could be any name you want, but let's keep it pub/sub because that's the default. And then you see here some metadata properties, and these properties are specific for RabbitMQ. So if you would use a different broker, for instance, NATS or Azure Service Bus, you will see totally different parameters here. So in this case, this is specific for RabbitMQ. We won't go into what this all means, but obviously you need to specify where the server runs. And in this case, it's just running on my machine. And as you can see, this is the port that I exposed. So I will be able to hit my RabbitMQ server running in my container or my machine. Another thing we do need to mention here is the scope parts. Because when you would use this component configuration file for all your services, then they would all be able to access this broker and they would be able to subscribe to it. Well, using these scopes, you can restrict the number of in the solution that will be able to use this this pub/sub component. So by doing this, I have created the configuration, and if I would now start one of the services with Dapr, and I specify this specific components folder, which we will do in a minute, then it will use these configuration files, and it will start using RabbitMQ. So that's all we need to do for configuration. The next thing we need to do is we're going to change something in the traffic control service, because if we go into the controller, then here at the end of the vehicle exit, so this is the exit cam entry point, if we have a vehicle exit, and once we have found out that there is a speeding violation, we will create a speeding violation message. In this case, this is just an object. And then now with the HTTP version of the service, we create a JSON message, and we will just post that using the HTTP client. And this is what we're going to change right now. So first, what I'm going to do is I'm going going to go into the traffic control server folder, and I'm going to add the Dapr package. So I'm going to add a package to my project. And here we go. And now you can see that a reference was added to the Dapr.ASP.NET Core NuGet package version 1.4.0. So that's something that we need because we want to start using Dapr in this project. The next thing we're going to do is that we're going to change this code here, and we're going to make sure that we use Dapr to send this message. So what I need is a Dapr client. So the first thing I'm going to do is I'm going to add a property here. I'm going to say from services, and then I want the Dapr client to be injected here. So by specifying from services, I'm saying that I want the Dapr client to come from dependency injection. Well, I need to add a using statement so I can use the Dapr client type. And now this is going to be used. And we're going to register the Dapr client in a moment. But for now, we have the client available for doing our work. And what we can do now is we can remove this code altogether because we don't need to create a JSON message ourselves, but we can just do something like this. So we're going to say Dapr client.publish event async. And then we have to specify the name of the pub subcomponent we want to use. Again, this is the same as the one that we specified here. And we need to specify the topic that we want to send it to. And then we can just pass in the object. And then the whole Dapr infrastructure will make sure that it will serialize this to a JSON message. And in fact, it will actually use cloud events, which is a standardized format for formatting messages. And this cloud events message will then be sent to the broker. So this is all we need to do. Well, in order to use this Dapr client, we need to obviously specify this and register this with dependency injection so it is automatically injected when this method is called. I could have also chosen to make this do this through constructor injection, but for now let's do it here for convenience. So I will go into the startup for my traffic control service, and then over here I will add some code to register the Dapr client. And this is a way of registering the client. This add Dapr client is an extension method that we got when we added the reference to the package. And as you saw also in the 101, you can add a builder to it to specify specific ports. And we need to do this because else we get port collisions. And in this case, the traffic control service will run the Dapr sidecar on 3600 for HTTP and on 60,000 for gRPC. And that's all there is to it. So now if we start this service, we can start sending messages through PubSub. So that's pretty easy. Now we're going to look at the find collection service, which will be the subscriber. So first what we're going to do is we open up the find collection service and we go directly into our controller. There are several ways of creating a subscription. So you could, for instance, create a subscription by using a component configuration file. So a subscription you can create, and then you can say, if you get a message in this topic, you will actually be called on a certain endpoint. Another way of doing it, and that's what we're going to do right now, is using attributes. So if you're using the Dapr client, and in this case, we already have a reference to the Dapr.ASP.NET Core package, so we already have Dapr on board, we could use an attribute for specifying which HTTP endpoint we want to be called when a message comes in to a certain topic on the message broker. So to do that, we're going to add an attribute to the collect find method over here. And this is a Dapr attribute. So I have to add a using statement so I can use this type. And then I can say the topic that corresponds to this HTTP method is speeding violations. And I wanted to subscribe to this PubSub component. And again, this is the name of the PubSub component to use. And this is all there is to it. So by doing this, I'm actually registering this HTTP method on my API to this topic through this broker. Well, in order to make sure that this works, I have to do two more things. First of all, I told you just now that when Dapr sends a message, it will actually create an envelope, which is a cloud event envelope, and that will contain the payload. Well, you could, of course, take in this cloud events object in your method and then unpack it basically and then get to the payload. But Dapr has some convenience for that. So what I can do here, I can say use cloud events. And the cool thing is now that there will be some middleware in the ASP.NET Core pipeline will be registered that when the message comes in, it will automatically be unpacked. And then the method that actually is called by the Dapr sidecar will just contain, in this case, the speeding violation payload. So that will automatically use JSON deserialization and model binding, and then the speeding violation item will come in. So that is something that I need to do. And then I need to do one more thing, because in order to make sure that Dapr knows which subscriptions I have provided with this service, so basically which method are decorated with this topic attribute, I have to specify something here. I have to map subscribe handlers. And what this does, this will create an additional endpoint on your server that Dapr sidecar will call once it's started. And it will just basically ask, give me all the subscriptions that you have. And then it will get back just a JSON message that will say, okay, this is a topic, this is the broker, and this is the actual endpoint that you need to call. So this is just a simple structure that specifies which method to call when a message comes in. And this is also part of the Dapr SDK. So that's all there is to it. So now I am able to get cloud events. I am able to specify which endpoint needs to be called when a message comes into the speeding violations topic. And then by virtue of this attribute, this will automatically be coupled. So let's see whether or not that works. So let's go back to our console and then start the services again in reverse order. So I'm going to start at my vehicle registration service, which hasn't changed, right? This is just the same service as before. So I'm going to start it the same way. And there we go. It's up and running. Then the find collection service. I'm going to start that. And as you can see here again, I'm specifying the components path. So I'm going one directory up, one folder up, and then into Dapr components, and then my RabbitMQ PubSub component will be found. This is also starting. And again, as you can see here, that the application has subscribed to the following topics: speeding violations through the PubSub named PubSub. So you see that this is actually working. And then again, start the traffic control service with Dapr, also specify the PubSub component, and then I can start my simulation. So here we go. And now it's waiting for a speeding violation, but yeah, as Sander already mentioned, people are basically anxiously to get home and start watching this stream. So people are driving pretty fast. So we see already some speeding violations coming in. And now, of course, the magic should be, there we go. So actually these speeding violations come into the find collection service. And if we now would open up the RabbitMQ management console, then we could see that there actually is some activity on my RabbitMQ. And if I go to the exchanges, I see that Dapr automatically created an exchange for us for the sending part, so for the traffic control service, called speeding violations. And you actually see messages coming in here. And then this is also bound to a queue, the find collection service speeding violations, which is the speeding violations subscription of the find collection service, which makes sense with this name. And now you can see that actually messages are being delivered because this line stays down here, which means that all the messages are being handled. If I now, for instance, would stop my find collection service, so I would do this, so the subscription isn't read anymore, then we will probably see this going up because messages will not be picked up from the subscription because there's no handler anymore. Here we go. So now basically my queue is filling up with speeding violations. And now when I restart the find collection service again, it will start picking up messages. Now for demo's sakes, we actually created a delay in here. So you see that it is waiting some time every time a speeding violation is handled. So, but what you can see here now is that basically the queue will be emptied and all the messages will eventually be read and handled. And the government makes money, so that's really important. So let's wait for it to get to now. So that's it. Now we're actually using PubSub to sending speeding violations from our traffic control service to our fine collection service. And it works like a charm. With that, let's give it back to you, Sander, and I guess you're going to talk about state management, right?
Yeah, I am. So thanks for that PubSub demo. I really especially like how the message handler is now simply part of your controller. And
Exactly,
you don't have to write that whole message loop, handling loop anymore. It's really nice, I think.
It's all handled by the Dapr sidecar now.
Yeah, really sweet. All right, so let's switch to state management. Now, I've already showed you a quick demo of state management in the beginning of the workshop, but in this part, I'll elaborate on that. First, let's do again a quick recap of what is it that a state management building block does. So state management allows you to save these key value pairs in a pluggable state store, and it's really meant for storing transactional or hot state. So, for example, the contents of a shopping basket would be a good fit, or the state of an ordering process, something that can be stored as key value pairs. So it's not designed to be a complete replacement for a relational database. So don't use it to store your entire registration of all of your customers in there. All right, so how does this work? We've got our app, we've got a sidecar, and if we want to store a key value pair, we simply make a call to the Dapr sidecar. That call includes the state store name in the URL, and then in the body, you include the state that you want to store. Then Dapr will look at its configuration, and it will use the selected infrastructure to store the data. And as you can see here in this Star Warsy example, you can store simple types, basically like strings and ints, but really you can store anything that's JSON. So you can store more complex objects in here in that value. But again, if you're concerned about performance, don't store like a gigabyte of data in a single value. Then if you want to retrieve that value from the store, you simply make another call to the sidecar. You again include that state store name inside, or in the URL. You also include the state key to query on, and then you get back the result. All right, so pretty simple. There's more advanced stuff you can do. So for example, you can use transactions on state stores that support it, but for now, we'll just focus on the basics. So let's look at our architecture diagram again. We will focus on the traffic control servers again. And at the start of this lab, the traffic control server simply keeps the vehicle state in an in-memory store. So it's not persistent at all. Every time that the service is restarted, all state is lost. And it's our job to fix this and make sure that that vehicle state is safely persisted. All right, so another demo time. Let's switch to my Visual Studio Code. And let's go to the traffic control servers. And let's open up that traffic controller class again. All right. So here we can see an instance of the iVehicle state repository being injected in the constructor. And then in vehicle entry, you can see where we make use of that repository. So here we are saving the vehicle state by calling the save vehicle state. And the state itself is this simple container object, which contains a license number, an entry timestamp, and then also an exit timestamp, but we don't know what the exit timestamp is at this point yet, so we don't set it. So here we call the repository, and then in the exit or the vehicle exit method, we again use that same repository first to load the state based on the license number, and then we update the state and then we save it again. So let's see how that repository is implemented. And currently that is being done in this in-memory vehicle state repository. You can see it uses a concurrent dictionary to save the state directly in memory. So right now, this is not stateful at all. If you restart the app, this will be lost. Not ideal for issuing traffic fines. So let's change this. Now, I'm first going to store the state in a Redis cache, and then I'll show you how we can easily switch that configured state store to a different store without touching any code. I'm going to that Dapr components folder that Edwin created in the last demo. Let's open up this state store. And if you look at this type field, this is still the same as the default. So the type is state.redis. It contains the same Redis configuration. And we can add one thing to this configuration just to tighten up security a little bit. We can add a scope. So with this scope added, Dapr ensures that only the traffic control service is authorized to use this state store. And this component will simply be invisible to all the other services. Now with this configuration set up, let's create a new implementation of the repository interface that uses this state store. So let's go to repositories again, create a new file, and I'm going to call this Dapr vehicle state repository.cs. Let's add some boilerplate code. Okay, so there's not too much in here yet. This class implements the iVehicle state repository interface. We've got this private constant containing the name of the state store component that we want to use. And finally, we've got get and save methods that we'll need to implement. Now, in the first demo of this workshop, I've already shown you how you can work with Dapr state management directly from an ASP.NET controller. And in that demo, we used model binding to automatically load state entry objects from the state store. But in this case, we're not directly inside an ASP.NET controller because of that iVehicle state repository abstraction. So here, we will use the Dapr client class to interact with the state management API. So let's start by injecting that Dapr client into this class. So here we are, and I think I need to run a .NET restore because it doesn't know that I've included the .NET SDK yet. So let's make double sure that I did. Yeah, it's right here. So this is just VS Code that doesn't know about it yet. So let's run .NET restore. All this red stuff should go away. Yep. All right. So we inject that Dapr client into the constructor and we'll save it in a private field. Now we can implement the getVehicle state async method like this. Paste in the code. Okay, so here we call Dapr client.getStateAsync to load the state from the store. And we pass in the name of the state store we want to use, which is saved in that constant, as well as the key to query, which in this case is the license number. So this method will return the stored state associated with that key if it exists. And otherwise, we'll get back the default value for vehicle state, which is nil. Now let's implement the right side. So what we see here is we call the save state async method of the Dapr client. We again pass in that state store name as well as the key. And now we also give it the actual state to store. And this object, of course, needs to be JSON serializable. So this is all the code we need to implement this repository. So really not a lot of code. Now there are some more advanced settings that you can use when saving states. And you specify those by specifying a state options object. And the first thing I wanted to talk about is this consistency option. You can choose between eventual and strong consistency. And this is applicable to state stores that are distributed themselves, like Customers DB, for example. So with eventual consistency, the state store writes the update to a single replica before returning to the client. And after that time, the state store will asynchronously update any other replicas. So eventually, all replicas will get the update. Now, with strong consistency, the state store will write the update to all replicas, or at least a required quorum of replicas, immediately before returning to the client. Now, not all data stores support both consistency levels, and if the option isn't set, the default behavior is eventual. The other option you can choose here is concurrency. So you've got two concurrency modes. Now, in a multi-user application, there's a chance, often a pretty big chance, that multiple users will update the same data concurrently or at the same time. And Dapr supports optimistic concurrency control to manage these conflicts. Specifically, when saving state, you can choose between first write wins or last write wins. And last write wins is the default. And it's also what we're using here in this demo application. So with this approach, the state store will always allow the update and override any existing value. And the other approach is first write wins. And that approach implements optimistic concurrency control using e-tags. Now, an e-tag is just a simple value associated with a specific version of a stored key-value pair. And each time you update the stored value, the associated e-tag value will change as well. So you can use this e-tag value when making updates to ensure they only succeed if the e-tag hasn't been changed by some other client in the meantime. So let's say if I wanted to use optimistic concurrency control in this repository, I would first need to introduce e-tags. So instead of calling get state, I would do something like this. I would call get state and e-tag async, and that returns the state as well as the associated e-tag. And then this method should then not just return a vehicle state, but also that e-tag to the caller. And then when saving the vehicle state, we should let the caller pass in both the vehicle state and that e-tag. And then use the try save state async method instead of the save state async method. And that method will succeed if the e-tag, which we pass in here, in the state store is the same as this one. Because that would mean that the value hasn't changed in the meantime and it's safe to update. For now, though, this repository is really simple. It can simply override any existing values. So we'll just keep working with the default value of last write wins. But I quickly wanted to show you that you do have those options if you need them. All right, now let's open up startup because currently our in-memory vehicle repository is still being injected. We don't want to use that one anymore. We want to use our updated Dapr vehicle state repository. So let me change that. Now we are ready to run the application. So let's start the traffic control service. All right, and let's go over to the simulation and start that one as well. And of course, this should all work. So we should see some traffic flowing. I already started defining the vehicle service, so we should see those speeding tickets coming along and the vehicle registration service is also running. Now, let's peek inside Redis to check if the state is now really stored in Redis. So I can do that by executing a docker exec command, tell it the name of my Redis container, which is Dapr Redis, and then tell it to execute the Redis CLI inside the container. So now I'm connected to Redis, and we can list all the keys, so all the stuff that Redis has stored, by typing this Redis command keys and then give it a pattern. So the pattern is just star to show all the keys. And we can see two types of data here. So first, there's our banking account, if you remember that from the first demo. And then we've got all these keys from the traffic control servers. Now, as you can see, those keys are being prefixed by the application identifier. And that's important because that allows multiple Dapr services to use the same Redis instance without getting into any conflicts. So if I quickly copy one of these and I do a Redis hgetAll, then I get the complete value for that key. And you can see that we've got the license number here and the entry timestamp and the exit timestamp. So it's really in Redis. Now, the cool thing about Dapr, of course, is that the state management building block supports different state stores through its component model. So without changing any code, we can now replace the Redis infrastructure with something else, like Azure Cosmos DB. So let me switch over to my Azure portal. And here you can see I've got a Cosmos DB instance already set up in my Azure subscription. Let me see. Let me go to the Data Explorer. And I've created a traffic state database, which has a cameras container. And I can create a new query to see what's in it. So basically select everything in this container. Let's execute that. And we get back exactly 0 results. So it's currently completely empty. Now, to make the switch, I only need to go to my state store configuration and change this manifest spec here. So let me replace this. And now I've configured it for Cosmos DB. So my type is now state.azure.cosmosdb. Here's the URL for my database. Here's the master key for my database. So please don't hack my database, or at least not in the next 5 minutes. Here's the name of my database, and here's the name of that collection. So let's close this up again, open up the terminal, restart traffic control, traffic, and then restart simulation, .NET Run. And then I need to find my Edge window. Here we go. Let's see if there are already seven key value pairs in here. So here you can see the for R621 blah blah, the entry timestamp, the exit timestamp, the license number. So extremely easy to change the underlying infrastructure. And that's really great if you have some infrastructure in production that is hard to test against. Then you can swap that out for something simpler in your development environment. So that's some really powerful stuff. So that's the state management building block. Next up on the list of topics is output bindings. So over to you, Edwin.
Yes, definitely. Thanks. Great overview of state management. And it always amazed me when you just change from one store to the other with just configuration changes without any code changes. That's really cool. So that really proves Dapr, basically. Now we're going to look at output bindings. So let's look at how output bindings work. As I said in the introduction, output bindings is a great way of basically integrating with all kinds of systems that you don't want to know how to integrate with. That's basically the poor man's description of output bindings. So from your application, you could, for instance, send an event to some system through a binding. And in this case, it's a piece of data, the message hello world, and an operation. And we'll go back to operations in a little bit. But you send that to your Dapr sidecar over the API. And then the Dapr sidecar, based on the name of the binding component that you specify here, so this is an important part of the configuration, it will send this message to the specified output binding. And this could be anything. It could be an event hub, it could be Redis, a Kafka, but also Twitter or Twilio, for instance. And then based on the configuration of this send event component here, it will send it to the backend system. So this is how that works. So from your application perspective, you only need to know the Dapr API. You need to specify the name of the component, and Bob's your uncle. So if we go back to the Dapr traffic control architecture and we look at where we use output bindings, well, we do that in the find collection service. So we're actually going to use an SMTP output binding There's actually a binding that is pretty near to my heart because I actually wrote it. That was the first piece of Go that I ever wrote in my life. Yeah, that was really great, and it's a great way of learning Dapr by contributing components. And we're going to use this SMTP binding to send messages to this, as I told you before, this development SMTP server that I'm using. So let's dive in and go to Visual Studio Code. Here we are back in the solution, and we're back at changing things here. And the first thing that I'm going to do is going to add an output binding component configuration. So I'm going to add a file here and going to call that email.yaml because we're sending emails. And then we're going to paste in a configuration for an output binding. So let's go over this binding configuration. It is a component, obviously. The name is sendMail, and the type is bindings.smtp. So now we know that we're going to use an SMTP server. And again, we have some metadata that is specific for the SMTP component in this case, because I need to know where is my service running, my SMTP server, on what port, what is the username password. In this case, I'm using the defaults from the development SMTP server. It's not very secure, obviously, but we're going to look at secrets later on. And there's something called skip TLS verify. And this is something that is really handy in testing scenarios because you don't want to set up all kinds of TLS and certificate stuff. So I'm able to connect to this SMTP server without TLS, which is great for a test environment. Obviously not for production. And that is why my SMTP component will actually give out a warning when I use this. And it says, well, this is not for production. And then, as we saw before, we specify a scope to make sure that only defined collection service can access this email output binding. And we'll see this output binding configured. So that is the binding configuration file. And again, this is important because this is the name that we're going to use for calling this output component. Then we're going to go into the find collection service, and we're going to find the place where we actually send an email, and that's in the collect find method. And you already see a to-do here below that makes that we have to implement because it now doesn't send any emails by default. So if we look at it at the method, first of all, we're going to calculate the find. Then we're going to get the vehicle info from the vehicle registration service, and then I log something to the console, and I also create a string for the find because that can be either an amount in euros or the string to be discussed by the prosecutor if you go over 40 kilometers or faster, if you speed more than 40 kilometers. So if I have that information, I will start building up my email. So first of all, I have to create an email message. And for that, I've created a utility class that creates an email body, which is basically a template with HTML with some placeholders there. And then I use the speeding violation, the vehicle info, and this find string for building this email. And you already saw that when I showed the example. So that's not really complex stuff. The next thing that I need to do is when I send something using an output binding, I have to specify some metadata. And this metadata is specific for each binding. So in this case, I'm using an SMTP server. And obviously, I have to give it some information as like, where does the email come from? So who is the sender of the email? In this case, it is just a made-up email address, and it's fixed. But the email too is obviously the email of the owner of the speeding vehicle. So I get that from the vehicle information that I got from the vehicle registration service. And then I need the subject, which is just speeding violation and then I specify the road ID from the speeding violation, because we have people in the Netherlands that are really bad and will drive fast everywhere. So if they get multiple speeding violations, they know which road it was on. So that's really important. And then we have all the information of actually calling the binding. So let's invoke the binding. And again, we're going to use the Dapr client. And then we're going to say invoke binding async. We specify the name of the output component, or the output binding, in this case sendMail, which we specified in our component configuration file. We give it the body and the metadata. And then there's that operation again, so that command. Each output binding can specify which, and I will go back to the email Yes, here we go. So this is the one that's already done. And to show you that this send mail is the same, I forgot to mention that. So this send mail will correspond to this one. And this command is basically this provided by the output binding. So in this case, I'm creating an email. This could also be a read or a send or whatever. And it's up to the component to specify which will be supported. Now, in this case, I only support create because I can only send emails. Well, obviously, we need the Dapr client again. So I'm going to add it to the method. I'm going to say from services, Dapr client. We have to make sure that we use the right namespace so that is injected when I get started. And then finally, if we look here, we have to specify the Dapr client. So I'm going to register the Dapr client here. An important thing to notice here is that we also have an add Dapr here. This is something that is from another assignment. And if you did not already add the Dapr client to dependency injection, this method will also do it for you. And if you already did it, then it will skip that. And in this case, I want to do it explicitly myself because I want to specify these ports to prevent these port collision on my local machine. So that's all there is to it. So I registered the Dapr client and I used the Dapr client in this collect find method to eventually send this email to the SMTP server. So that's all the coding we need to do. Now we're going to see whether or not it works. So let's go to the console. And the first thing I'm going to do is I need the SMTP server. So I'm going to start, just as I did before with RabbitMQ, I'm going to start the SMTP server as a container on my machine. And it will be listening on port 4000 for the inbox UI that you saw before, and on port 4025 that you also probably saw in the configuration of the email component. And I'm using a DTC MailDev. And MailDev is the server that I use for this. It's a pretty cool development tool. So now that is running on my machine, I'm going to start the services again in reverse order. So first, the vehicle registration service. That's up and running. Now, the find collection service, which will eventually start sending emails. The traffic control service. Well, you saw this before, so I do it quite quickly. And then .NET run the simulation. And then if I go again to the MailDev server, you see my inbox is empty now. And then when the speeding violations start coming in, there we go. We also see the emails coming in from the find collection service. So that works like a charm. So with that, let's go back to the slides. And I'll give it over to you, Sander, for talking about input bindings.
Yes, let's talk about the other side of this equation. So as you just saw, output bindings are used to invoke external systems, and input bindings are quite the opposite. They can make your application react to external events. So you can think of these as triggers for your code. And of course, there are a lot of components that you can use. So here are a couple of them. So let's say you want to trigger your application anytime a message comes in over Kafka. So you would let the sidecar handle that by just creating another component configuration file. And the sidecar does the hard work of connecting and polling for messages, so you don't have to deal with any of that complexity yourself. Now, when the message comes in, the sidecar will call your application over plain HTTP, and it will also pass in that payload. And this keeps your code completely free of any SDKs or libraries. The application just waits for another HTTP invocation. And Dapr will also handle any retries and failure recoveries. So back to our architecture diagram. Now up to this point in the exercises, the camera simulation has used plain HTTP requests to call the traffic control servers. But in this next demo, we'll change that and we'll use MQTT to call the traffic control servers. Now, MQTT is an OASIS standard messaging protocol. It's a really lightweight protocol that's often used with IoT devices, so it's a great fit for our traffic cameras. This is a bit of a diagram of what the MQTT PubSub architecture looks like. So on the left side, there's a publisher, which publishes messages to a specific topic on a broker. And on the right side, there are clients that subscribe to the topics to receive those messages. And if we apply this to our traffic control situation, then the camera solution will publish the messages. For the broker, we use Mosquito, which is a lightweight open source MQTT broker. And then we've only got a single subscriber, which is the traffic control service. And of course, we will not be sending temperatures, we'll be sending camera events. So let's make this work. Let's switch back to my Visual Studio Code. And first off, let's open another terminal window. And let me show you that Mosquito is actually running. So I'm going to show the Docker logs of the DTC Mosquito container. And here you can see it runs. It listens on 2 ports, 1883 for MQTT, as well as 9001 for WebSockets. It's not doing much at the moment. It's just running and waiting for connections. Now let's start by making any necessary changes to the traffic control service itself. So this will be the service that is going to receive those events. So again, let's go to the traffic controller class we know and love. We've got our vehicle entry. We've got our vehicle entry method, which is just a post of entry cam. We've got our exit method, which is opposed to exit cam. So currently being tracked as HTTP request. Now to change this, to use input bindings, we actually don't have to change anything in this code. Nothing whatsoever. Remember that when a Dapr input binding is invoked on the sidecar will simply make an HTTP request to the application. So as far as the traffic control service is concerned, there's no difference. It's just being called over HTTP, and it has no knowledge of any input bindings. What we do have to add, though, is a component configuration file for the input bindings. So let's go back to our components folder, and let's create one for the entry cam binding. So let me paste it in. Here we go. So this is called entry cam. This is really important, by the way, because this name must be the same as the route of the web API that you want to be called. So this name here must be equal to, let's go to entry cam, to this path. Then, of course, we don't need a namespace. Then we've got a binding of type MQTT. We've got our connection info to connect to the MQTT broker. So port 1883 is the default MQTT port. We want to subscribe to the traffic control / entry cam topic. And then each subscriber also needs a unique consumer ID for MQTT. And in this case, we'll just let Dapr figure one out. And we can do that by using this template for UUID. And we also scope the use of this configuration to the traffic control servers. And that's really important because all of the services use the same directory to load the component configurations. But we only want the traffic control service to react to the entry cam messages. So that's why we scope this here. All right, so let's add another configuration, this time for the exit cam. For exit cam. Oh, it's already there. So I don't need this for this demo. So here we've got the exit cam with almost the same content in this configuration file. The only difference is that now it's called exit cam and it listens to a different topic. It listens to the exit cam topic, which makes sense. Okay, so now that we've added these two component configuration files, let's go back to the terminal and start the traffic control servers. It loads the components, so now it can be started. Oh, and now it can be called over MQTT. So now we need to change the simulation to send events over MQTT. And if you follow the exercises in the workshop, then that's exactly what you do. You change this simulation. But I think I've got something better. So I've written another simulation, which is a graphical simulation that runs in the browser and is written in JavaScript. So let's use that one instead, just to change things up a little bit. So I need to find it somewhere in my repositories. Source visual simulation should be in here. And let's open up one of the files. So in my root folder, there's a settings file. What's interesting here is that here you can see that this visual simulation that I wrote supports both HTTP as well as MQTT. And right now it's configured to send events using MQTT. And it will connect to my local Mosquito broker, which is running on localhost or 127.0.0.1. Now, it doesn't use the standard MQTT 8083 port. Instead, I'm connecting to 9001, which is the Mosquito listener for MQTT over WebSockets. Because this is JavaScript, this runs in a sandbox in the browser, and it cannot establish a direct MQTT connection. So I'm using MQTT over WebSockets to get around that and connect to Mosquito. So let's run this. Oh, I meant to focus my terminal window first, so let's run this. But this will start a .NET application that hosts that JavaScript application, and we can go to it by going to localhost 5000. So let me get a Chrome browser in here, and let's go to HTTP localhost 5000. And here you can see the simulation run. So there are a lot of cars we can scroll around, have some parallax scrolling. Oh, that red guy is going pretty fast. We can zoom out and we can zoom in a bit. So you can play around with this. It's fun. It's also up on GitHub. We'll probably share this link as well at the end of this session. Now let's switch back and see what happens with the rest of the applications. Where's my Visual Studio Code? Here it is. So first of all, let's have another look at Mosquito. So you can see that there's quite some connections happening. So this is working. And if you look at traffic, you can see that the traffic is still coming in. So this is all working fine. Traffic service doesn't even know it's being called through input bindings. It's just the same old code with the same HTTP endpoints in just an ordinary ASP.NET controller. So to summarize, it's really easy to use input bindings, only adds a bit of configuration. Now, let's have a look at the schedule, because this is my demo for input bindings. And I think if I look at the time, this is a perfectly timed break.
Yep.
Let's break for like 15 minutes. Then we can start at a 10:45 Pacific Daylight Time again. Does that sound good, Edwin?
Yep. 1:45 is fine for me.
All right, 1:45 it is. So see you soon.
Bye-bye. And we're back. So if we look at the schedule, the big gray part is everything that we did up until now. So it's already quite an impressive list of building blocks that we talked about before. I hope the people in the stream are still awake. For us, it's now, what is it?
It's not too bad. Quarter
to 8 at night. So and
feels like it's later though. But
yeah, it is. But
no, but we're in the home stretch, Edwin. Final topics.
Yeah. So secrets management, and then we're going to look at actors and observability. And like we said, secrets management is basically the last assignment in the hands-on workshop, and then actors and observability are basically our bonus tracks that we do on the live coding. So I hope you will stay on the stream to also see those. And then of course we have time for some Q&A, and we will dive onto the YouTube channel and get all your questions in. So without further ado, let's look at secrets management. So secrets management is really important because often you don't want any information, or you have information in your application that you don't want to publish. You don't want it to be disclosed. And we've all been there as developers. You have some hard-coded password or whatever in your code or in your configuration files, and then you push to GitHub and it's out in the open. So that's something that you don't want. And obviously, we have lots of tools nowadays that can scan your repositories to see whether or not there are any, if there's any information in there that you don't want to share, some sensitive stuff. But of course, to prevent is way better than that. So that is where secrets management comes in. So there are lots of secrets management tools out there. So you have Azure Key Vault, HashiCorp Vault, AWS has a Key Vault, but also secrets within Kubernetes has also a secrets component. And you can leverage that using Dapr without actually needing to know all of them. So how does that work? Well, it gets a little bit boring, but again, here we have an application with a sidecar. And obviously, as you might expect, the Dapr sidecar has an API for getting secrets. And in this case, you have to specify the name of the vault that you're going to use, which is basically the secrets management component name that you provided, and then the name of the secret. And then when you call this API, the Dapr sidecar will call into the configured vault. So here you see a couple of the examples, AWS Secrets Manager or HashiCorp Vault, and then get the information back. And then the application can use this information for logging on to a server or whatever. And this way, everything is secure. So you don't have to check it into to GitHub. So pretty cool stuff. There's another way of doing this, and let me start with adding a big disclaimer here. This is possible, and this is great for demos. So I'm going to use it now in the demo you're going to see, because it's very easy to show how secrets work. But this is not for production workloads, because obviously this local file is something that you still have to put into GitHub, and then of course this will be out in the open. So this is not for production. Please let that be clear. But this is purely for demonstrating how secrets work and what the secret management API can do. So let's look at the code. We'll go over to Visual Studio Code, and you can see the solution that we've built up until now. You see all our components. We have the email component, the entry cam, exit cam for the input bindings. We have our prop sub component, etc. So everything is working great, as you just saw in Sander's demo. And now what we're going to do is we're going to add some secrets to it. And where are we going to use these secrets? Well, we're going to use that in the find collection service, because the find collection service has some credentials, as I told you before. So we have a username and a password for authenticating to the SMTP server. And also, if we go into the code of this collection service, you see that it uses a find calculator. And this find calculator is just a hard-coded find calculator. So this is purely demo code. Obviously, this is not what you do in production. But this calculator is some kind of an external library, and there's a very elaborate security check on there. So if you specify a license key that is not this exact string, again, it's demo code, then you will get an invalid operation exception that will state there's an invalid or no license key was specified. And then the find collection service cannot use this library. And this key, it will get it now from just the configuration, so the .NET configuration. So if I now go to my app settings file, I can see that there's a find collector license key in there that actually is just also hard-coded. And this could end up on GitHub, and that's not what we want. So both the credentials for connecting to the SMTP server, as well as this hard-coded license key, we want to get that from a secret. So first of all, what I'm going to do, like I said, I'm going to use the file-based secret provider, and this is, again, not for production. So I'm going to add a file, and I'm going to call that secrets.json. And this will actually hold the secrets that we want to use. And I have a snippet for that, and this is just a piece of JSON, and it has 2 blocks in there. It has an SMTP block, which has a user and a password, and a username and a password. And then the find calculator has a license key that contains this very secret license key. So this is the secret file. Then we're going to configure a secrets management component because we want to use the Dapr secret management building block. So we're going to add a new file, which we're going to call secrets file.yaml. And we're going to paste in the secrets management component configuration file. So again, this is a component. The name that we're going to give it is traffic control secrets. So this is the name of the vault that I had to specify on the URL that you just saw when calling the Dapr API. It is of type secret store.local file. So I'm using the local file secret store component. And then I have to specify where this file is. And this can be a bit strange at first, because if you look at the path that I specify here, this secrets file is obviously in the same folder as this secrets file configuration file. But what I have to do is I have to specify the path of the secrets.json file with respect to the folder that I'm starting from. So when I started in the vehicle registration folder, for instance, I go again back up 1 folder, then into Dapr components, and that's where my secrets.json is. So always relative to the place where I start my application. Another important thing to mention here is the nested separator. And this is a way of specifying that if you have something like this, so if we go to the JSON file, you see I have basically 2 sections, and I have an SMTP section and a find calculator section. And each of these sections have multiple or can have multiple keys in them. Now, what you can do with this by specifying this this nested separator is that the names of the name of the secret that you want to get, you can specify that using the name of the section, and then the delimiter, so in this case is that the dot, and then the name of the secret. So smtp.user will get you this secret, and smtp.password will get you this secret. Now, that's something that you can specify. You could also use an underscore or whatever, but you can specify that. So that is our component configuration file done. So now if I specify this when starting a service with Dapr, it will be able to access the secrets file. Again, to make sure that not all the services can access it, we add a scope that only the find collection service will use this secret component. So that's the configuration done. So then there are several ways of using these secrets. So first of all, what you can do, you can, of course, in your code, using the Dapr SDK for .NET, you can call into the Dapr secrets management building block and get a secret. That's what we're going to do in a minute. But there's another cool way of using it. And that is you can actually use it directly from an other component configuration file. So now we're looking again at the email configuration file. We use the SMTP binding, and we want to specify the username and the password for authenticating there. Well, we can actually get these from the secrets component or the secrets building block by specifying that in a certain way. So I will remove this, and I will replace this with this. And now you can see that several things were added. So first of all, we added an auth section here in which we say the secret store that we want to use is traffic control secrets. And this obviously, again, corresponds to the name that we provide for our component configuration. So that's how the link is made. And then when specifying the name and the password for connecting to the SMTP server, instead of just using a plain value, we specify a secret key ref. And then we say we want the name and the key. And here you can also see this separated character, the dot. So I can say smtp.user and smtp.password. And this is the way you can actually get the username and the password from the secret store and use it when this component configuration file is run. So that is what Dapr handles for us. And again, if I now would switch in this configuration file from a local file to, for instance, Azure Key Vault, and then specify the necessary metadata here, then this secret would actually be coming from Azure Key Vault without any changes. So that is pretty cool. So this is how you use a secret from another component configuration file. Now let's look at how we're going to use it in code. So let's go back to the collection controller. And as I stated before, here you can see that I get this find calculator license key. I get it from the configuration file. So what I can do is I can replace this with this. So I can say Dapr client.get secret async, and then I specify again the name of the vault or the Dapr component that I want to use, traffic control secrets, and the license key in this case. So here you see this separator character, find calculator.license key. And then in this result, there is the find calculator license key value, and that is what I eventually set in this private field. Well, as we've seen before, in order to use the Dapr client, we must provide it here. So it's injected using dependency injection. And because this is the constructor that I'm doing it, so this is the constructor of the collection controller, I don't need to say from services. So I'm using a constructor injection here. And if we go to the startup, in an earlier assignment, we already added the Dapr client, so we don't need to do that again. So the only thing we need to do is specify it here, and it will automatically be supplied by dependency injection. So let's see whether or not this works. So the proof is in the pudding, as they say. We go back to our console application, and we're going to be starting all these services again in reverse order. So first, the vehicle registration service, the find collection service, and the traffic control service. And then we'll start the simulator. And everything should work as before. So we're going to wait on, oh, what's going on here? I know what's going on here. I didn't start my Mosquito. Where am I? So that's what was wrong here. So let me restart the traffic control service. Application. Okay, so I broke it now. Let's do something different. Oh, there it is. I will show you what happens when it goes wrong. So to actually prove that it is using the secret, what I will do now is I will change the secret. In this case, the license key. I will just change it to something that is not valid, and then start the service again, and then we can see what happens here. So vehicle registration service is still running. Find collection service, I have to restart it now. So there it is. Start the traffic control service. And then start the simulator again. Here we go. And now it starts sending messages. And so the first error was that my broker was not running. And now when we look at the find collection service, here we go. Something goes wrong. And if we look at what happens here, then we get an invalid operation exception, invalid or no license key specified. So we see that it actually works. And then when we stop the find collection service here, and we go back and we change it to a valid one. So it is valid again. And then restart the service. This one's already running. And then restart the simulation. Then eventually we will see fines coming in or speeding violations coming in. And it all works again. People are not driving as fast on a Windows machine than on a Mac. Here we go.
It's Apple Silicon. That's the,
Yeah,
that's
it was.
the difference.
Yeah, just it struck me that you have a lot more violations than I have on my machine. So probably your machine is faster, probably. Yeah. So, but that's how secret management works. So it's pretty cool stuff. So with that, let's go back to you, Sander, and we're going to talk about
Actors.
Yeah, cool.
Yeah, we are. So let's switch to my screen. And let's talk about Dapr actors, or also called the actor model. So the actor model is actually pretty old in computer years. It originated in 1973. And it was proposed by Carl Hewitt as a conceptual model of concurrent computation. So that's a form of computing in which several computations are executed at the same time. Now, really highly parallel computers weren't really a thing at the time, but the more recent advancements of multi-core CPUs has made the actor model popular again. So what exactly is then an actor? Well, an actor is an independent unit of compute and state. And actors are completely isolated from each other, and they will never share the same memory. Instead, they communicate with each other by sending messages. Now, the reason why the actor model makes writing concurrent systems easier is that it provides a turn-based, or also called single-threaded, access model. And in this model, multiple actors can run at the same time, but each actor will process received messages one at a time. And that means that you can be sure that at most one thread is active inside an actor instance at any one time. So to demonstrate that, let's look at this example of a counter actor. Really simple actor. It simply keeps track of a counter value. And let's assume that there's a message sent to this actor to increase the counter value by 1. So the actor will start executing that operation. Now, while it's busy doing that, a second message comes in to increase the counter value by 2. However, because of the turn-based model, that second message will be blocked until the first operation is completed. So once that first operation is completed and the counter has been set to 1, only then will the second message be handled and the counter will be set to 3. Now, in this example, we are executing the same add operation, but it is worth noting that turn-based concurrency is respected even across different operations. So to summarize, a single actor instance is only doing one thing at a time. And having such a model means that you don't need any locking mechanisms in your code to deal with multiple threads. And that makes writing correct concurrent and parallel systems much, much easier. Now, actor instances or actors are hosted in your servers. And to provide scalability and reliability, the actor instances are partitioned across all of the instances of your servers. So let's say my actor service is running in a Kubernetes pod, and I scale it out to 2 instances. The actors in my application will then be partitioned across those 2 service instances. And if something happens, if one of the partitions fails, then the actors will be moved to a healthy partition. So that's great for reliability. Now let's look a bit closer at how this partitioning exactly works. So the Dapr placement service that you may remember from the beginning of this workshop, which is running in one of those containers that you get when you initialize your Dapr environment. So that service is responsible for keeping track of where all the actors are hosted. So let's say, hypothetical scenario, we've got applications A and B. And application A contains an actor, application B contains an actor type called counter. So when a new instance of application B is started, the sidecar registers the supported actor type, so the counter actor type, with the placement service. And then the placement service calculates the updated partitioning information, broadcasts that information to all of the instances. And then each service can cache and use that partitioning information to find actor instances. So let's look at an example of calling an actor instance. Let's say we still have that application A, and application A wants to call an actor that's part of application B. Now, application B is now scaled out, so we've got 2 pods. And in the first pod, there's an active actor called X. And all these applications have received the updated partitioning information from the Dapr placement servers. So when application A wants to call actor X, it will invoke an operation on its local sidecar. No surprise there. The sidecar will use that cached partitioning information to figure out that actor X is actually located in pod B1. So then it will forward that request to that sidecar. And then finally, that remote sidecar calls the actor instance. Different scenario. Now let's say application A wants to call actor Y. Well, that's interesting because actor Y doesn't exist in this diagram. However, it will work perfectly because Dapr's implementation is based on the virtual actor pattern, which was originated by in Project Orleans. And with the virtual actor pattern, you don't need to explicitly create actors. Actors are activated implicitly and placed on a node in a cluster the first time that you send a message to them. And that also means that when actors haven't received any messages in a while, they will be automatically unloaded from memory again. So there's some automatic cleanup going on. Now, don't worry about your actor state. No state is lost because that actor state is safely persisted using the state management building block, actually. So when an actor instance reactivates, its previous state will simply be restored. So going back to calling actor Y, what happens is application A makes a call to the sidecar. Sidecar uses the partitioning info to find a host for actor Y. It will find out that pod B2 is the perfect host. So the call goes to the sidecar in B2. And then the sidecar calls the application. The application will activate that new actor instance and will apply the message to it. So that's how actors work in a nutshell. I think this is enough theory for now. So let's go back to VS Code. All right, some more code. And we'll start with the traffic controller again and with the controller class specifically. So let's have a final look at this constructor. So we've got a logger, we've got a HTTP client. We don't actually use this HTTP client anymore at this point in the workshop, so we should probably get rid of that. Then we have the state repository to save some state, and we have the speeding file lazy calculator, which contains some logic for our for this controller. And then, of course, you have still those entry and exit methods. So if you look at this class, then the behavior coded in this class fits the actor model pretty well. I mean, we have these small units of state that consists of an entry and an exit timestamp. And then we have some logic that these units must perform on that state to find out if there's traffic violation. And finally, all those units are independent from each other because each unit only deals with a single vehicle. So this might be a good fit to apply some actors. So let's see if we can rewrite this code to use the actors building block. And we should start by defining an interface for our actor. So inside the traffic control service, I'm going to make a new folder and call it actors. And inside that folder, I'm going to create a new interface. So let's call this iVehicle actor. And let's add some code to this file. So here we are. Now, this interface will be used by clients to invoke operations on the actor. So this needs to contain all the methods that we want to be able to call on that actor. Now, as you can see, this will not build in its current state. We are missing a Dapr.actors assembly. So we need to add that additional package. That's a separate package from the rest of the Dapr.net SDK. So let's do that now. There are actually two packages for working with actors. So you've got Dapr.actors, which includes the core classes and interfaces that we need to develop actor services using Dapr. And then you have dapr.actors.asp.NET Core that provides integration with ASP.NET Core. And because we want to host this actor in our ASP.NET Core servers, I'm going to add a reference to the second package. And that package also includes a reference to that dapr.actors package, so I don't need to add that other one explicitly. Okay, so now you can see all the red squigglies are gone. So let's see. Our interface contains two methods, one for entry, one for exit. And I simply reuse this vehicle registered message that we also used in a controller. So if we jump in there, that object contains the lane, the license number, and the timestamp. Now, this object must be serializable using system text JSON to be used in an actor method like this. And there are some other constraints as well. So the return type of an actor method must be task or task of T. And if you have a task of T with return type, then that return type T must be serializable as well. Also, actor methods can have at most one argument. So if you need to pass in any complex data, you need to do what we've done here and use a container object that contains all the data that you want to pass in. All right, now let's implement this interface. So I'm going to create a second file and call this vehicle actor. Go to this file. So here we've got our vehicle actor class, which derives from actor, which is a class from the SDK. And we implement, of course, our vehicle actor interface. Now note that this constructor here, it takes a host argument of type actor host. And this actor host class represents the host for an actor type within the actor run type. And you need to accept this in your actor and then pass it on to the base class. All right, so let's implement this first method, the register entry method. Oh, let's not make any typos. All right, so let me get rid of those squigglies first. Add some using statements. And now let's look what this implementation does. So first off, note that the actor base class exposes this logger property, which we can use to write some informational logging. So no need to inject an iLogger instance ourselves. We can just use that property from the base class. And then the only thing we need to do on vehicle entry is to save the incoming state. Now, I don't need our custom Dapr vehicle state repository anymore that we created a couple of demos ago. Instead, I can simply use this state manager object, which again is exposed by the actor base class, to set the actor state. And then the actor runtime will ensure that this state is persisted when this method is finished. So let's look at our second method, the register exit. It's also pasting some code for that one. So at this point, the vehicle has reached the end of the speed camera zone. And the first thing we do is we get the state from the actor. That state should always exist, right? Because the camera should always send an entry message before an exit message. But of course, a lot can go wrong with IoT devices, so we check for it anyway. So we've verified that it's not nil. If we cannot find a state, we simply throw an invalid operation exception and let the caller deal with it. But what I wanted to demonstrate with this check here is that thanks to the turn-based access model, we don't have a race condition here between these two methods. So I don't need to worry about the register entry method updating the state while I'm validating the state in the register exit method. These two methods will never run at the same time for the same actor instance. And therefore, I don't need to use any explicit logging mechanisms in the code. So once we've got that state, we can now do something with it. So let's add some business logic. So let me see. In this business logic, we can have some squigglies because this code uses two external dependencies. So first off, our speeding violation calculator, which we know and love. And then if there's a validation or if there's a violation, we of course use our Dapr client to publish an event. Now, we've used to do these, we've used to resolve these dependencies using dependency injection. And luckily for us, actors also support dependency injection. So any additional arguments that you add to the actor constructor are resolved using the .NET dependency injection container. So let's replace this constructor with this new one. And of course, I need to add some additional using statements. Let's do that right now. So here you can see in the constructor, we've now got the required dependencies and we save them in these private fields. So if I scroll down to the exit method, you can see that all the squigglies are gone and this will work. All right. So our actor is basically done at this point. Let's go back to that original controller and change it to use this new actor class. So let's go to traffic controller, and I'm going to replace all of this code. So let's get rid of it, paste in a new one. Let's start with a constructor. So this new traffic controller constructor takes an iActor proxy factory, and we'll use that class to create clients to call our actor instances. So let's see how that works in the vehicle entry async method. So vehicle entry is still being called over HTTP posts, so we can still call this method just by using the CUDAL simulator with an HTTP request or using the updated simulator with an MQTT input binding. Then when we're in this method, we want to call our actor. And to invoke an operation on an actor, we of course need to know where it is or how do we address it. And we need two parts for this. So first off, the actor type uniquely identifies the actor implementation across the whole application. And by default, the actor type is the name of the implementation class without its namespace. So in this case, the type for our actor is vehicle actor. Now, if you want to, you can customize the actor type by adding an actor attribute to the implementation class, and then you can specify a different name. Now, the second part is the actor ID, which uniquely identifies an instance of a specific actor type. So here on line 26, we create a new actor ID based on the license number. So we use the license number as the unique identification for all vehicles. That seemed to make sense. Then on the second line, we use that injected proxy factory to create a proxy instance for the vehicle actor. And that method takes two arguments. So the first one is our actor ID. The second one is the name of the actor type. And it also has this generic type parameter to specify the actor interface that we want to use to communicate with the actor instance. And of course, the actor type must implement this interface for things to work. So now that we have this proxy, we can create or we can call actor operations on it. So in this case, we call register entry async, and we pass in the message that we received in the controller. Now, very important thing here is remember that the Dapr placement service distributes actor instances across all the Dapr sidecars. So this actor that we're calling could be located on another instance of your servers, on another node, which would mean it is a call over the network. So from a performance standpoint, just always assume you are going to make a network call when you're calling an actor. If you're lucky, the actor is hosted on the same node where your calling code is running, but it could be on a different node. Now, the other method, the exit method, is virtually the same. The only difference is that now, of course, we are calling the register exit operation on the actor instead of the register entry. Okay, So we are getting pretty close to actually running this thing. Last thing we need to do is to make some changes to the startup file. So let me open up startup.cs. Now to host actors in an ASP.NET Core service, we must add endpoints for the actors. So this is a little bit similar to what Edwin showed you with PubSub, where you would add a PubSub subscription endpoint in order for the Dapr sidecar to discover what kind of subscriptions there were. This is basically the same. We are creating an actors endpoint so that the sidecar can discover what types of actors we provide, we can handle. So that endpoint is necessary. The other thing that's necessary is we need to go to the configure services method. And we need to register support for Dapr actors by calling add actors. And then using this options object, we need to register our actor. So once we've done this, once we've run add actors and registered our actor, that actor will be made available through this actors mapping endpoint. All right, so I think we're good to go now. Before I start this, remember that our state store component is configured to store actor state, right? So let's maybe double check. Let's go to state store. So here you can see that metadata property actor state store and the value is true. So all the state from the actors will be saved using this component. So it will end up in Redis. Okay, now let's start the server. So let's go back to my terminal. I'm already in the traffic control servers folder. So I start this up. See if we get some application logging. Yeah, so this looks good. Vehicle servers, fine. Collection servers already running. So I can go to simulation. Oh, by the way, before I show you that, have a look at this log here. Here's an entry in the log about placement table updates. Here you can see placement tables update version 0, placement tables updated version 1. So when the server started, the Dapr sidecar registered our vehicle actor type with the Dapr placement servers. And then the placement servers then calculated that updated partitioning info and broadcasted the result to all those service instances. So if you look at the logs of a different service, which was already started, such as the vehicle registration servers, then you can also in its log see that it received that update from the Dapr placement table. So each service now has a cached copy of that partitioning information and can use it to invoke the available actors. Now let's go to the simulation and run it again. And now we see the traffic flowing again between services. If I go to the correct log, so here it goes. Fine is running, vehicle is running. So everything is running. Looks perfectly fine, but now it's running using actors. All right, so let me switch back to PowerPoint for a minute and show you something else. So let's say we now want to add a new feature to our application. Consider what could have happened in this special scenario if we receive an entry event for a vehicle, but we never receive an exit event within some expected time frame. Now, obviously, there aren't any exits in our stretch of highway. If there were, we would add some extra cameras at the exit ramps. So what probably happened is that the vehicle broke down and it's now stopped on the side of the road. Now, wouldn't it be great if we can detect this inside our actor and then send him some roadside assistance? So how will we implement this? Well, if we define the moment that the vehicle drives under the entry cam as timestamp 0, then we would expect that vehicle to drive under the exit cam at some timestamp X in the future, where X, of course, is high enough to also allow for slow moving trucks and that sort of thing. So maybe we can send a notification to ourselves in the future to check if the vehicle needs help if we haven't detected it. And of course, these notifications should be created and cleaned up for each individual vehicle, so there's quite a lot to keep track of. But fortunately, we've already created an actor to represent a single vehicle. And with the Dapr actor model, it's really easy to schedule notifications inside an actor. And there are actually two types of notifications that we can use. We've got timers and we've got reminders. And both support the configuration of a due time. But the difference between the two is the lifetime of the callback registrations. So to explain that a bit more, timers will only stay active as long as the actor is activated. That means that if no other operations are called on the actor, it will eventually be deactivated and the timer will be stopped. Reminders, on the other hand, are persistent. So when an actor is deactivated, the reminder will continue to exist and it will reactivate the actor when it fires. So now let's see what this looks like in code. I don't remember if I shut down everything. Did I? Simulation is shut down, traffic is shut down. Okay, so that's good. Let's go to our actor. Let's make a little bit more room and go to the register entry method. So once we've done all the saving of the state, we should set up a reminder for the detected vehicle. And we can do this by calling the register reminder async method on the actor base class. So that method takes 4 parameters. So the first is the name of the reminder. And that's necessary because we can register multiple reminders for a single actor. And the second parameter is used to pass any state to the reminder callback. This must be a byte array. Anything you pass in here is available when the reminder fires. And then we've got these 2 time span parameters. So the first one is the due time for when the reminder must fire. So in this instance, I want it to fire in 10 seconds. And the second one is the time interval between invocations after it first fired. Now we only need to have this reminder fire once. So in this case, I'm specifying -1 to indicate that I don't want the reminder to repeat. So it will only fire once. So now that the reminder is registered, let's go over to the register exit method. At this point, we know that the vehicle was detected by the exit camera. So we know it's not somewhere on the side of the road broken down. So we can safely unregister that reminder. So for that, I use the unregister reminder async method of the base class, and I pass in the name of the reminder that I want to unregister. Now, the final thing to add is the code for when that reminder actually fires, so the callback code. Now, if your actor uses a reminder, it must implement this interface called iRemindable. And iRemindable declares a single method. It's called receive reminder async. And in this method, I first check if the vehicle last reminder is fired. Now, my actor only uses a single reminder, so this check is not really necessary, but you can imagine this being useful if your actor registers multiple reminders. I then load state from the state manager, and I log a warning that we should probably send in some roadside assistance. Now, it's important to note here that both reminders and timers respect that turn-based access model. So when the reminder fires, this callback will not be executed until any other method invocation or timer reminder callback has finished. Also, while this callback is executing, no other method invocation or callbacks will be allowed to run. And again, that makes it much easier to write concurrent applications. So let's test this out. So first, let's restart the traffic service with my new actor implementation. So that's running. Let's go over to the simulation and let's start the simulation. Okay, now I'm just going to let it run for a bit. So now we've detected some vehicles on the entry cams. So I'll cancel this simulator in a second to prevent any exit events from coming through. So let me cancel this and then move back to the traffic. And there are already some warnings. So these are warnings coming from the reminders who have detected an entry event but haven't detected the exit event in 10 seconds after that. So the reminder will fire and it will call for the roadside assistance. So that is the Dapr actor building block. Let's switch back to Edwin now for the final building block in this workshop, which is a really important one, observability.
Yes, observability. Thanks for that actor part. I really love actors. I just wanted to mention that if you can remember, some time ago, I did also a traffic control demo with akka.net.
Mm-hmm.
And it is really cool to see that conceptually, but also almost if you look at the code, it was basically the same. So if you know actor model and if you know how to use these reminders and messages to yourself, you can really build very simple software. You don't need any synchronization code whatsoever, and then by sending messages to yourself, you can do really cool stuff. So really great addition to Dapr.
What's also very nice is that if you've got an existing code base that uses Service Fabric reliable actors, then this SDK looks almost exactly the same. So it's very easy to port that application to Dapr.
Yeah, pretty cool. So let's look at observability. Obviously, observability, as Sander already said, is very important. If you have a distributed application, you have multiple running parts, and you really need to know what's going on. And anyone that has built a distributed application probably knows that it's quite hard to get good insights into what is happening within your application. And there are lots of tools out there, lots of libraries that you can use, but sometimes it's really hard to get that to a state that you actually can use it for troubleshooting and monitoring your applications. Well, in this part, I'm going to show you that when you use Dapr, a lot of that stuff comes out of the box. You don't have to do anything for that. So how does that work? Observability is really something that we can basically divide into 4 categories. And like I said, observability is about what's going on. And more important, what is broken within your application. And the 4 categories of telemetry, as we call that, so the data that comes from your application is called telemetry. We can basically divide it into the categories distributed tracing, which gives you insight into end-to-end traffic, so traffic flowing through multiple parts of your distributed application. Metrics, this will give you insights into performance or resource consumption and all that stuff. So how many CPU and memory you are using, but also what is the average request time span and all that stuff. That's what metrics give you insights into. Then you have logging. Logging is often something that comes from your application, but also from the Dapr sidecar. And we've seen a lot of logging today already. So basically all our demos are built on this logging that you see when you start these Dapr services on the command line. So that's also really important. And that's also often something that comes out of your application, not just from Dapr, but also from your own application. And then finally, the 4th category is health. So you see more and more that services offer some kind of a health endpoint, and that's also true with Dapr, which you can call, and then you can see whether or not this service or this component is up. So that's really important. So this is quite a big topic. So for this part of the workshop, we would like to focus on distributed tracing and on metrics. So we're going to dive into that. So first of all, distributed tracing. How does that work? Well, actually, there is a specification called the W3C trace context specification. And this basically works by injecting some kind of a correlation token in each request and response that is part of a certain request chain, so to speak. So if you call a service and this service calls another service and that service calls one or multiple other services, then this correlation token is injected at every hop. And then by using this correlation token, you can basically correlate all these calls together and get an entire call chain together. That's really cool. Well, because Dapr works with a sidecar pattern, and because this Dapr sidecar is doing all the communications between the services, it has a lot of knowledge of all the requests and responses going out and coming in. So the really cool thing is that you can configure tracing for Dapr, and then the sidecars will actually collect all this telemetry. So it will inject these correlation tokens, and then it will push this telemetry to a well-known endpoint. And then this well-known endpoint, you can use that to get this data and put it into some monitoring backend, for instance. And some examples you see here on the slide. Zipkin is something that is installed with Dapr, but you could also use Jaeger or New Relic, for instance. And one cool thing about Dapr is that because Dapr does more than only service-to-service communication, as you saw with service invocation, it also does pops up, and it also does triggers, and it also does state and all that stuff. So what we will see in a moment is that when Dapr does that, it will automatically give you all kinds of information about all these types of communication between different parts of your application. And that is really powerful. And you basically don't have to do anything for that. So the application that we've built, we didn't do anything with correlation tokens in the request, whatsoever. It's all Dapr doing that. So how does that work? Well, here you see an overview of an application. In this case, there are two services, service A and service B. And if they communicate with each other, then from the sidecar, these telemetry will automatically be pushed to a server. And in this case, you see on the top right, you see a snippet, which is the default configuration file for Dapr, which we saw before. And you see that tracing is enabled here with a sampling rate of 1, which means that every metric or every telemetry is sampled. And the endpoint which this Dapr sidecar will send this telemetry to is this Zipkin endpoint. And it's running on localhost port 9411. And this is how you can use a Zipkin server. And like I said, Zipkin is automatically installed when you start Dapr, and when you install Dapr. So how does this work? So let's look at this scenario. I have a service A, and this will call service B, and then service B will call into service C. So what happens under the covers is this. Service A will call service B. And then when the Dapr sidecar is forwarding this call, it will push this telemetry to the Zipkin server. And then a trace will be started, because this is the first hop in eventually a chain. And then you have a span within this trace that says, okay, service A is now calling service B. Then when service B calls into service C, again, through the Dapr sidecar, obviously, because you're doing service invocation in this case. When this call is done, the telemetry will again will be sent to the Zipkin server, and there will be additional data. So now we know that within the span AB, also a new span is recorded from B to C. And that is part of the call chain because there was no response back to service A yet. So, and by reading all these telemetry that comes into the Zipkin server can give you these kinds of overviews. Now, then when service C responds, also in this response, the correlation token will be used to add this to the existing trace, and then we see that the span will be expanded. And then finally, the response goes back from service B to service A. The same thing happens, and then basically this trace is done, and you have an end-to-end insight. Because the Dapr sidecar also records timestamps of these occurrences, you also have already all kinds of information around how many time how long does a request take, or how long does a certain call within this chain take. So also when you have a slow call chain, you can use this information for pinpointing the slowest part within this chain. This is very important for troubleshooting and optimizing performance of your distributed system. So how does that work? Let's look at distributed tracing with Zipkin. So I'm going to go back to my Visual Studio Code. And now we're going to run the application a little bit differently. So we have been running in self-hosted mode until now. But as we stated, Dapr can also run in Kubernetes. So I have the entire application here, and I also have a Kubernetes folder with all kinds of manifest files, which are basically the configurations files that we saw before. So if I, for instance, open the email server, then you see the same component configuration. And as we said before, these are just custom resources for Kubernetes. So this is something that you will recognize. But also all the services itself, so the fine collection service and the traffic control service, they will be started in Kubernetes. And one of the things to mention here is that you see that using annotations, you can make sure that a Dapr sidecar is automatically injected. So Dapr IO enabled is true. We'll make sure that the Dapr sidecar is injected. And then by using these additional attributes or annotations, as they call them, you can specify the configuration that was basically sent on the command line when we did it with in the former demos with the self-hosted way of rolling. So this way you can start the services within Kubernetes, and then the Dapr sidecar is automatically injected. So let's start the application now. I am in the Kubernetes folder, and I have a convenient way of starting everything at once. So everything is started. By the way, we will share the link to this repository, which is basically the Dapr traffic control sample application. Everything is up on GitHub, so you will be able to use this and look through all these scripts if you're interested in that. So what happens now is my application is started. If I look in Kubernetes and I go into the namespaces, I will see that there's a Dapr traffic control namespace. I will use this. And then if I go to the workloads and I look at the deployments, you actually see all the stuff deployed. So I have a fine collection service, I have a mail server, Mosquito, RabbitMQ, the whole shebang, everything that we showed you in this workshop is now running in Kubernetes on my local machine, so in Docker desktop. So it's just one node, obviously. So now the application is running. What I also deployed within Kubernetes, because if you install Dapr on your local machine, a Zipkin server is automatically added. But in Kubernetes, you have to add it yourself. And you saw Sander deleting some namespace in his demos. In this case, we want to use namespaces because we want to have all the resources for the Dapr traffic control application in this same Kubernetes namespace. So what you can see here is that I also deployed a Zipkin server. It just uses a standard Zipkin image that's up on Docker Hub, and then it started, and it runs on port 9411. And that is also the port that we saw in the configuration file. So if I open the Dapr configuration file that is used, you also see here the tracing being configured and also the endpoint being configured. So if I now open up a browser and I go to localhost, and then it was 32411. So Zipkin is running on this port. Maybe I have to show you how that works. If I go back to the Zipkin one, I have a server here, and I expose the port 32411, which maps to the 9411 port within the container. So that's a little bit of magic going on, but not anymore. And this is Zipkin. So what I can do now is, because my application is running in the back, I can run a query and I can see all kinds of informations. So I see here, for instance, a call to bindings/exit cam on the traffic control server. And we know that this comes from our simulation. And if I open this one, I can see there are several servers involved in this trace, so to speak. So we have the traffic control service, we have the fine collection service, and the vehicle registration service. So this was actually a speeding vehicle. And if we now go into the details of this one, you see an entire trace, just as we saw before with these individual spans, that spans multiple services, but also multiple communication mechanisms. So first of all, we see the binding, the input binding coming into the traffic control service. That's recorded by Dapr and pushed to Zipkin. Then we see get state. So also state management communication is recorded in here. So you see that it gets the state. And because this is an exit cam, it will also save the state again with the new exit timestamp. Then we have the traffic control service. It does a publish event. And because Dapr handles this, we can also see that the publication of this event is also recorded. So the fine collection service picks it up, etc., 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 all the way to the vehicle registration service. And this is basically a service invocation call. You also see all the timings in here. So you can see exactly which of the calls are the slowest calls within this call chain. So that's very valuable information. Another cool thing with Zipkin is that if I go to dependencies and I press search, we can actually get an overview of which services are calling each other. So you see that the traffic control service calls into the fine collection service, and this calls into the vehicle registration service. And all this information is for free. So I didn't change anything on the application. It is all because Dapr handles all these communications that it can record this information. So this is pretty gnarly stuff. Back to the slides. The other category of telemetry that we talked about was metrics. So metrics is information basically on resource consumption and performance. Basically, you can also have other metrics. You can basically also push custom metrics from your own application, but most of the time it's CPU memory and request response latency and stuff like that. Also, again, because the Dapr sidecar handles lots of stuff around your application, the sidecars. Oh, let me dismiss that. I thought it was on focus, but didn't work. The sidecars can provide all kinds of information that contain these metrics. These metrics are, you can use Prometheus compatible monitoring backends for visualizing this data. So you can do it with Prometheus itself, or you can use Grafana or Azure Monitor or New Relic. So it is quite open standard based. And there are 3 levels of metrics that you can get from a Dapr sidecar, which is metrics from the system services. So for instance, the placement service or the sidecar injector service. You can get information from all the sidecars in your application. And if you're using actor model, you can also get information from actors. So it's pretty elaborate what you can get. So how does that work? Well, basically a little bit the same picture, but now the telemetry is not pushed to an external server, but the Dapr sidecar will provide an endpoint, and this endpoint can be scraped, so to speak. So what you can do is you can actually add Prometheus to your deployment. So in this case, we're running in Kubernetes, so we can add Prometheus to our Kubernetes cluster, and it will start looking for Dapr services. And then when it finds the Dapr sidecar, it will call a well-known metrics endpoint and scrape the data. So this is important. So it is basically a pull model from your monitoring perspective versus the push model when your Dapr sidecar pushes information to Zipkin. So if you have that set up and Prometheus is providing all these metrics to you, then you can set up some monitoring backend. And in this case, we're going to look at Grafana, which is a pretty cool tool. And then what you can do in Grafana, you can specify the Prometheus server as a data source. And if you do that, data will start flowing into Grafana. And then there are, at this moment, there are 3, but maybe there will be more in the future. You can specify certain dashboard configurations or dashboard definitions, which is just a JSON file, which you can get from the GitHub repository of Dapr. And then once you imported these dashboards, you actually get all kinds of metrics about your services. So let's see how that works. So I have Grafana already installed on my machine. I'm not going into how that works because it's completely described in the Docker documentation. But I have Prometheus and Grafana running on my machine. And I will now go to, let me first port forward to Grafana. So Grafana is running on my machine and it's exposing port 8080. And I can then connect to that. And now when I go to localhost 8080, I will get to the Grafana dashboard. What I've done, I've already got an administrator account and a password. Again, this is all described in the documentation, how that works. And now I'm logged on to Grafana. Now what I need to do is I have to add Prometheus as one of the data sources. So I can go to the configuration of Grafana, go to the data sources and say add data source. And there are several data sources that you can use, but we are using Prometheus and therefore we're going to use that one. Then I have to give this a name. So let's name it Dapr. And then I have to specify the host name of your Prometheus service that is running within your cluster. Well, I've already determined that. Again, this is all also part of the documentation. And now I can say save and test. And yes, my data source is working. So actually data is now coming into Grafana from our Prometheus service. Well, the last thing I now need to do is I have to create dashboards. So what I will do is I will go to Manage Dashboards, and then I will say I want to import a new dashboard. And then I'll go back to Visual Studio Code, and then I will grab the definition for the, in this case, let's look at the sidecar dashboards, because those are pretty important. Like I said, it's just a bunch of JSON. I won't go into what's in there because you need to be a specialist. I'll just paste it in and load it, and then I will say, okay, import this one. And now you can see that I get telemetry. And because the service has been running for some time, so let me go back and pick the last 5 minutes, you actually see all kinds of telemetry coming in. So we're now looking at the Dapr traffic control namespace. We're looking at the find collection service, and we can see what's the uptime of the sidecar. We can see total CPU usage of the sidecar, how many go routines, how many bytes of memory I am using, latency of outbound requests, latency of inbound requests, all kinds of telemetry about your service coming from the sidecar, so you don't have to do anything for that, comes from the services, which is pretty cool. You can actually also see how many components were initialized. If you're doing actor, you get actor information. There's some security information in there. So this is pretty elaborate. And I'm now looking at the find collection service, but all my services are in here. So I could also create a dashboard that gives you an overview over all the services, and it will then show this information side by side. So this is pretty cool. Another one that I can add, and that's the last one I'm going to do, I can also, let's discard this, that's not very important. I will import the system services dashboard. Import. And here you see all kinds of information about the system services. So here you see the Dapr operator, what's its uptime, Dapr placement service, Dapr Sentry for security and certificate type stuff, and the Dapr sidecar injector. What's the total memory usage? What's the memory usage of the CPU and memory usage? How many sidecar injection requests? How many successful sidecars injected? Etc. etc. So it's a big set of information that you can use to monitor the health of your distributed application. So that's pretty cool stuff, in my opinion. So with that, we are actually at the end of the stuff that we wanted to talk about. So I guess we're doing awesome on time. I guess we're
doing pretty great for a change.
Yeah. So
I did already see one question in chat about where we can find the code for the actor and the observability samples, because obviously they're not part of the workshop exercises, so they're not in that repository.
Yeah, I will send a link to the Dapr traffic control. Actually, the observability stuff is in there. I added it. You didn't even know that, so that was added yesterday.
I didn't.
So if you want to look at this Grafana stuff, I added an observability folder to the Dapr traffic control repository, and I will add a link in the chat in YouTube, so people can see that. And actually, well, it's also up here. So it's the Dapr traffic control sample application. So if you go to this this repository, then you will find.
We're not seeing your PowerPoint slide.
Oh no! Okay.
Oh yeah, there it is. It's the third link, right? The Dapr traffic control sample app.
Dapr traffic control. And by the way, this is also the sample application that we used for the book. So if you want to read the book and then use the sample application for learning more, that's a great way to do it, because all the examples in the book are basically based on this traffic control sample. So it all ties into each other. And you can do the workshop, of course, afterwards. So maybe if we look at the comments.
So I was looking through the comments, Edwin, and a lot of the comments have already been, or a lot of the questions have already been answered by Willem. There is a new one coming in. Does the sidecar list to metrics from the application as well? So you showed that you've got that metrics endpoint, right? And it pushes all these sidecar metrics. How about your application metrics?
No, you have to do something for that. So that's something that's also still a little bit in construction. So if you want to add metrics from your own application, then you have to do something for that. So you have to basically push them yourself to the Prometheus endpoint. So it is possible. There are libraries to do that for .NET and all the other programming languages, but you have to push them yourself to the Prometheus service. And obviously, you also need to create a dashboard then in Grafana to listen to these metrics.
All right, and staying on the topic of observability, how would you implement centralized logging in Kubernetes? So you've discussed metrics, right? You've discussed tracing. How about logging?
Yeah, well, of course, you have the logging that comes out of the Dapr sidecar and of your application, what we've seen in the examples. So all the logging about speeding violations and entry and exit cams, that was logging that came out of our application. And that was just dumped to the console. So in this case, it's the standard output that it was dumped in. The Dapr sidecar logging is also dumped there. So basically what you can do is you can scrape your standard output of your container, for instance, if you're running in Kubernetes. You could, for instance, say, I will set up an elk stack, so Elastic, Logstash, and Kibana. And if you work with the elk stack, then you have things that are called, and I have to do it by heart, but because I'm not an expert in monitoring, they're called beats. So you have several beats, file beats, if you want to scrape some logging file, or you have also beats that can scrape the standard out of a container. And then you can send it all to the Logstash, to the Elastic server, and then it gets ingested, and then you can search it and create indexes on it. So that is how you obviously see that implemented in production.
Yeah, so your sidecar logging, you can capture your application logging, you still need to emit it yourself and just push it up to the same sync.
Exactly.
Then you've got your centralized logging. Yep. That sounds good. So there's a question, could you refer to the SLIM model and does it deal with concurrency? Now, I'm not 100% sure that I'm on the same page with you. I know there's a SLIM init mode where you can initialize Dapr on your local development machine without using any Docker containers. That doesn't have any different behavior concerning concurrency, but maybe we can elaborate on this over in the Discord channel and have some more time to deal into this. So a quick question about correlating logging. Well, as far as logging goes, so tracing is correlated for you, basically. As far as logging goes, anything you want to log as part of your application, you would have to write yourself. So you can include, I know the name of your app, your app ID, stuff like that in your logging. And then when you've got it all pushed into this single sync, like in Edwin's example, if you push everything into the elk stack, for example, you can create dashboards and views over all those separate logs together, so you can correlate there.
Yeah, and what is important is that if you want to do that, always use structured logging. So that's also something that you can configure on the Dapr sidecars. That normally you will, as you saw in our example, it's just strings being logged. But if you enable structured logging for your Dapr sidecars and you use structured logging from your application, for instance, I always use Serialog, which is a very popular library that supports structured logging, then basically what you log will become an object, a JSON object. And this format is really good for ingesting into a search engine, because then you can search on these indexed properties that you put into the structured logging. So if you, for instance, have a functional, for instance, we could, for instance, say every time we have a speeding violations, we push a metric with the total amount of euros we have earned today. Let's think of something. If you would put that out through structured logging and then push that to an elk stack, so to an Elastic server, then you could say, okay, give me all these metrics with a certain name, and then you can search on them, and then you can find these metrics within all the logging that was pushed to the server. So structured logging is the way to go there. That's really important.
Yeah, definitely.
Yes.
So here's a fun question. Is there any performance penalty for not using actors.
Oh wow, how was me?
Yeah, I would say it depends.
It depends, yeah.
So the most important benefit that you get from actors is that term-based model, which really makes it easier for you to write correct concurrent code, introduce less bugs, and basically make a better system. Now, if that system, whether that system performs better or not than a different implementation, kind of depends on the different implementations. So the thing you have to look out for with actors is that basically any call to an actor can be a network call. So if you make a really fine-grained implementation with really small actors that are also really chatty to each other, then you get a lot of network traffic and you get a really badly performing application. If you size that right, so if you've got actors that still represent a single logical unit, but they also don't need to call a lot of other actors to do their job, they get a great performing system. And whether or not that is better or worse than a system not using actors kind of depends on the other system, but at least using actors, you will not run quickly into any problems with multi-threading because of the term-based model.
Yeah. And in terms of performance penalty, obviously, there always is a performance penalty in calling the sidecar, right? So if you could do a direct call to another service over the network, or you need to go through the sidecar and then to the sidecar, the other side, and then to the application, there is always a performance penalty in there. But it is really small and basically negligible. But that's always something to keep in mind. If you have a really high volume, high throughput, low latency scenario, then this could be too much for you. But always check whether or not that's a requirement for your system, because the latency is always there, but it's very small. And the teams does a lot of work in testing with every new release of the Dapr runtime to see whether or not this latency becomes too big. And they are actually really good at that, I think.
Latency is really small, and in a lot of scenarios, I gladly give up a little bit of latency to get back a lot of functionality that makes my life as a developer that much easier.
Yeah, totally.
So with that last question, we have come. Well, we're still over time, Edwin. I thought we were doing so well, but now we're still a minute late. So thank you so much for joining us on DaprCon Day 2. We've had a lot of fun. We hope you did as well. So thanks a lot. And I think we've got some last words from Donovan Brown to wrap this all up.
Yes. Thanks, everyone. Have a great day.
The entire DaprCon team wants to say thank you for spending this time with us and joining the Dapr community. DaprCon may be over, but the content and workshop are still accessible after today. Be sure and follow us on social media and join the Dapr Discord to stay up to date with the latest Dapr news. We cannot wait to see what you build. Take care, everyone.